Okay, testing, 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 hello, testing. Just testing. Testing, testing, testing. 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 Testing, testing. Testing. Just testing. Okay, looks like we're up and running. Just waiting for people. Let me just gonna wait. Let me cut comment waiting till 3 p.m. start. And hello to all. Okay, so just waiting for a 3 p.m. start. Well, it's 10 minutes from now. 3 p.m. start. Anybody jump in yet? Let me know. Let me see if I can move over. Yep. Okay, just waiting for 3 p.m. start. And let me try to queue up my own content here on my cell phone while I wait. And da 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 la 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 la. I should try to finish this within 30 minutes. Just so you know. Can you give me anybody that's here? Can you give me a sound check? Tell me how I can you hear on the mic? Requesting a sound check. Requesting a sound check, please. So you go into your live comments and you would comment if you know how to do that. I know some people watch from TV. You can't do it from there. Requesting a sound check, please. And you TV watchers, I know you can't do it. Yeah, where is the video? Well, I guess, and I'm also trying to confirm that you can see the live video stream. Sound check, please. Testing 1, 2, 3. Sound check, please. Let's see. Let's put this here. Yep, you can see that. So I want to do. Oops. That is a huge screenshot. Sound check. Shit, that's a huge screenshot. Sound check, please. Sound check, please. I'm gonna do it on sound check. Oh shoot! I just lost a window I needed. Hold on. Why is this in the way? Text. I'm gonna make that much louder. Sound check, please. Oh, great. That's not working that way, is it? And size would be way up here. Sound check, please. Can you, there we go. Sound check, testing. Well, I see it now. Never mind, someone sent me a text, so I can delete this and don't save. Okay. We're still waiting. Still waiting for 3 o'clock start. And there we go. Thank you. Sounds good. Thank you. Yep. I see the screen as well. Okay, thank you. We're going to wait for 3 o'clock. We'll do the 3 o'clock start, so 6 minutes. You guys, I will only do, let me make sure something, screen background. Let me move that over. Maybe this one. I'll give you a couple of clues for you guys that are here now. Hopefully I don't screw this up. Let's see. Already did a good job of screwing that up. Hold on. Okay, here we go. I have two screens open. You guys can't see them both. So I have a screen to the right, screen to the left. Screen to the left is what you observe. Screen to the right allows me to preview first. This is very critical for what we're going to talk about today. And remember, this is a NIST report I got this from, this BMA. And this report that I guess I'm starting already, huh? I don't want to get ahead of myself. This is a NIST report from like the 80s or something, or 70s, or I forget when in the exact year. But I want you to take note that this is a BMA, is literally a post-tension with two post-tension bars. Now, that's the engineer and the engineer architect are dead. They do mention a beam type A. There is a beam type A inside the structure, but there's also a BMA. So, you know, talking the dialect of the time, BMAs is supposed to be a post-tension with two post-tension bars. It literally exist. So you would have to determine which one were they talking about. The whole building was self-certified by the engineer and architect. So you can't go to the municipality to say which one were they talking about. See, there's no dash between this BMA, beam dash A, beam type A. This is BMA. This is where I'm going to bring this into your. This dialect will be very important for you to know shortly. Let me move this out of the way. And let's see. We can start in another 4 minutes. You guys got the preview of it. Checking my phone while we do this. We're not going to really deal with this image yet. I didn't make it this far in the video. I literally have just doing the... Son of a bitch. I'm sorry, someone's blocking my driveway. I just got a message. I've got a camera set up to show okay, to show someone, you know, it's a driveway, a different location. I'll address that as I watch which house they walk. I literally can watch them. Guys, cameras are the way to go. You got to have some cameras on your house. I recommend a few cheap cameras because they're always updating the HD and all that. And you can't, at nighttime it's useless. They're mostly motion sensors at that point. Unless you've got yard lighting that can come on, or yard lighting that can illuminate the daylight. Okay. 2 minutes to kick off. 3 o'clock, and then I'll be able to delete. Let me see what I got here. Nope, did that one. Let me do my full screen again. Where'd you go, baby? All right, I'm ready. That's queued up right here. Slip this over for you, see if you can see it. Yep. This is going to be critical. Do you see the BMA here? Let's see. 2 minutes left. I'm almost ready to go. You know, I'm biting at the bit here to get you to, biting at the bit for the 3 o'clock, right? So I'm almost ready to go here. I'm ready to go. Let's just go for it. And I think I'm playing this by ear. I have some notes that tell me where to cue into the live video of the NIST report. And we're going to play it. And you have to tell me if it echoes on you. I'm playing from a speaker, and then you hear it through my mic. I have earpiece in, so I should be able to hear some feedback if it starts echoing weird. What's so critical here is they're going to talk about. I'm going to give away what we're going to. I'm trying to figure out. You know, I like playing Columbo, playing dumb first, but I'm just trying to think if I want to give you, right now, give you what's so critical, and then when they play it, you go, aha, at the same time. So I think I'll do that. Let's do that. Let me give you the, instead of going like Columbo would always tell you, he would always tell you at the end, he wouldn't give you this, to tell you to key on something, you'd have to catch on. So in this case, I'm going to tell you what to key on, and then I'm going to play the video. And then as you hear the data, to see if you catch it also. Now, they're going to talk about, so I'm giving it away right now. They talk about original plans, all right? They have a plans expert. They're going to talk about the original plans. Well, these are the original plans, all right? These are. And then they remove this BMA right here. See this design right here? They remove this. They remove this one here. This is the parking garage. I've done videos on this, you remember. This is, right here says 1 foot 0 inches. This says 1 foot 0 inches. Very critical for you. You guys know how long that is? Some of you men, it's big as your penis. It's about the same size as your penis. But for you to telling the truth, this is 12 inches, right? 12 inches. Yeah, I know. It's to some of you girls out there, you know, come on. Mostly I have an older audience, so you guys can take the humor. So this was the original design. It was to have a 1 foot step down onto this area here, which is the pool deck. Not to be confused with the parking deck here. This is the parking garage, parking area over here. This is where the lady from, this is the elevator shafts and storage room and, you know, stairways right here. I'm sorry, stairwell would be here. You come out the stairwell next to the wall. Correction, you come out the stairwell here. And you can come out here. So you come down the stairs, you exit here. Fuck, it's like 4 foot off this wall. I keep wanting to say it's over here, that you exit here on the stairwell. And then, yeah, so this is like the wrap of the stairs, and you exit, I believe there's a door, the door's there. And then there's a door here. And you look at that hook design, the rebar is hooked. All right, this is a step down also. They don't show it here, but it's step down because this is 1 foot. Or it's very even. There's steps over here too. What's critical also is this is 2 foot 6 here. 2 foot 6 inches. There's the BMA. This is the original design. The original design says this is 7 foot. Keep that in mind. 7, 11. Think of that. So there's 7. Here's 11. That's 11 foot off that wall is the next porch. This is a step down right here. There's steps coming off that porch of the unit 111, the nearest property. They come out into this balcony, if you will, their porch, and I'm sorry, porch, because it's a porch. And they come out to the porch and they walk down these steps and they can go to the pool deck. There's a planter box that would have been placed here. Original planter box with some shrubs around the deck area here. Of course, not in front of the steps. And then they added later another planter box out to here. This planter box is approximately 1 foot 6 inch to 1 foot tall, as stated by NIST. I'm saying 6 to 1 because I can't remember whether they said 6 or 1. I think it's like 1 foot tall. NIST will also state that the planter boxes that we see in the images are on the deck. Well, technically they're on the deck, but the load path is on top of a column. When we see those planter boxes, these are columns. Every time you see one of those big planter boxes that she describes, she'll state them as 3 foot tall, I believe. She doesn't give any other dimensions besides 3 foot. All right, so she doesn't say 3 by 3, 4 by 3 by 4. It's just like 3 foot tall approximately, because she mentions it with the dirt height, the soil height. And she says it's very, impactful, is what she's trying to imply. Well, it depends how impactful it is, what besides the soil, the water retention. But each one of these also has a drain in them. So there's drainage. So how impactful is it? How much does this dirt weigh? Did they weigh it? They could have weighed it because they had access to it here. They could have given us a rough estimate of what they think that soil weighs. But the plants, even with the big palm trees on them, they were still load path on top of columns. All right, on top of columns. They centered those damn things up pretty good. Now, she says, she'll state that it's not part. So again, I'm giving you the defects in their communication, and then I'm gonna play the video to show you it. She states that these extra planter boxes, they weren't part of the original plan. And so, I'm a bitching now, watch. So they're not part of the original plan. And so, yeah, that therein lies our major problem. And she, well, the problem is neither was this planter box part of the original plan, although she states it is. That's bullshit. It was not. This is the original plan. And the planter box was not designed to be on this side of the pool deck, on this side and this side. It was one or the other per the plans. These are the original plans. There's a 1 foot step down. This is critical because this introduces our BMA, our beams. And you can call it a beam type A if that makes you happy and disregard my NIST statement I just showed you. As long as we both understand that there was an elevation change of your size of your penis. I'm helping you remember it. Hey, Randy, 12 inches. All right? I'm helping you remember. This is the way I do things. I'm not just being... since they, just sexual, because they said I'm doing porn, right? So I'm going fucking all in. You're going to call me porn? Well, let's call it porn. All right. Remember, YouTube is now saying I'm porn, recommending. Well, here's your 12-inch penis for YouTube, got people. So you can now put me on porn, you cocksuckers. All right. So anybody seen the previous video, you know why I was so pissed and why I just said that. I don't think that will do anything. Because they used to keep me with Champlain towers when I try to make it towards that. So anyway, here's your BMA here, the 1 foot step down. Look at this. This thing stretches all the way from this wall. It comes all the way over to this wall. All the way across. And it's a long span from this column. Well, what the hell? Look at that. Oh, let me do this for you guys. All right, I know it's an overlay over an overlay you're seeing. I can see what you see in my right screen. So I know you're seeing the background of this, and this is the one I'm going to work on. And let's just use this. It's just a straight line. I can do it no matter what. It's a straight line. So let's put it at the back wall, and let's put it at this wall. And now, right here is a column. So let's do... this guy and this, let's make it I don't know if this works. Sometimes it won't show. Yeah, it's defective right now. This software is acting up, so let's delete that. Let's go with our circle there. I'm sorry, I gotta freehand it. All right, let's grab this, and that way you know it's a column there. All right, so this is what's noteworthy here is that that's that column. That's my K column, the one that is, out of square. So rectangular array. I keep wanting to say, oh shit, I just said it backwards. Rectangular array. I've got a really issue with that, I guess. So if we look back here, she does, and I mentioned this in another video. I said we don't really want to pick on these guys back here. This is off like 6 inches. See this right here? I did videos on this, guys. This is only like 6 inches difference. All right, let's delete that. You can see it with the staggered lines. They look like this. Oops, sorry. And that difference between these two, the center line of this column to this one. And this column is faced like this. All right? Take note of that. Is like that. And this column is like this. So there's a different behavior mode. Now NIST will show testing, and they're made up one section, and I don't even know if it's true to size, but they made up one section, and in the video they're going to show a point load that they're going to do this right here, and they're going to push down from here, like me just adding pressure from the sky, just pushing down. Hello, Tiffany. So like pushing pressure from the sky. Well, that's a false narrative. Remember, I'm telling you the content. I'm giving away what I'm going to now rip apart in a minute when we show the NIST video. They're showing it pushing from here. Well, that implies that all this is already separated, sheared off. This is what NIST is applying by making this one sample alone. Because this reinforcement, as you see here, it says 13 number 4s and 13 4s. They eventually interact with each other. So does the 10 4s and these 10 4s and etc. The deck is continuous. It's not a control joint there. So it's these engineers that NIST has, yeah, they may be professors and PhDs, etc. But they're piss poor engineers. They couldn't kiss my foot, right? I wouldn't let them lick my boot. They're that bad. They are that bad. Yes, you can use the halo effect. Halo and psychology says that I've been doing this 40 years, so therefore what I say is smarter than the person who's been doing it 1 year. All right, so I've been doing it at the same time they're doing it. They became professors, teachers, PhDs, and we know that in engineering, this is not a joke, guys. In engineering, most people that get PhDs are normally going into the academic side of it, which is usually not a problem until you cross from academic to now think that you can do evaluations in the real field. You were academically having sex. You didn't really have sex. You remember the first time you had sex, guys? The first time I had sex with a girl didn't know it was my first time. I didn't tell her. I didn't know what the hell I was doing. She didn't teach me because I didn't tell her. So it was a different thing. So remember, they throw me in with sex now, so I can talk about sex, so I can make sure that I'm having fun with the person who's monitoring me, obviously, that says I'm going to put you a porn. So how do you like that? I can, remember the guy that we now kissing made up, the engineer from Ronald Ing, how he said you should name the cat. He was trying to troll me, Forensic Cats, your channel. And so what did I do? I named the channel Forensic Cats for a while. I enjoy a good piece of humor, all right? So the person that's watching me, you think you put me in porn. Well, I'm doing this content because of the sponsors of the channel. Christine just sent like multiple donations all at once. So I do get donations from PayPal too, but you guys, it's get your full name on it. I'm not going to, put your full name out here to say thank you. I've seen other people do it on their channels. I humbly thank you, but I don't, unless you give me permission to publish your name, I'm not going to do that. And of course we have Carolyn that takes care of the cats significantly also. She's a great supporter, and everyone in the private channel, and you guys give them comments. So that's why I'm doing this still, because that flood of support that came in after that release of the porn. All right, so let's go to of them putting my channel with porn suggestions. So this is a control joint they've made. It's totally separate by their sample when they press here, and they say, this will tell us how it reacted here. I'll show it to you in the video. I have it all queued up in the paper that I'm whispering in the background. But by me telling you this now, you're able to say, aha. You can call bullshit as I'm calling bullshit. So this is giving you the background. All right. So this is the remember rectangular array. And incidentally, they do not talk about rectangular. Yeah, I said it right. I thought I said triangular array again. Rectangular array. This means that the steel is not. If you look at this is what I show in one of my videos, and I'll get to it. I'll show that again. This is not squared. Now, do they know it's not squared? Right? Do they know it's not squared? See, this would be squared. There's the column here. This is offset also by a few inches right there. Well, per ACI, you're allowed some deviation. Now, what I want you to keep track of, you see this column? It's much larger down here. It's going to give you more surface area. But this column out here, see this one? This is there's a difference. All right, all these columns out here, and I did this in another video, are very different than the columns here and here inside the parking garage. And that this is the deck. I'm going to draw the deck, right? So that's your deck, and here's your column. All right, hopefully it straightens up. Yeah, it did. And so the deck goes across the column like this. Of course, we could add the steel in. I don't have to do it yet. And so it's got a full head support of, say, 12 inches on top of here, 12, whatever the size of these are. All right, 12 inches of head support. On these columns over here, it doesn't look like that. And on these columns, this one, and this one back here, they're the tower columns, and these guys back here, they belong to the tower. And with that said, the deck, okay, butts up to the column. So let's look at the top view of a column. We're looking at the top view. All I did was make this, and I put it out here. The decks butt up to it. All right, they butt up to it. They don't go through it. And let me reserve that. Let me reserve that statement, because you're going to be able to tell me whether they go through or not later on. They don't go through it, right? Yeah, this is like a Columbo move now. They don't go through it. I'm trying to think if I'm going to give you the... Remember 12 inches again. The significance of 12 inches. And I want you to be able to leave this part back here where you can say to me, yes or no. Right now I'm going to say, they don't go through it, but don't believe me. Don't believe me, all right? Don't believe me. Should I give it to you now? I'll put this off to the side and I'll start talking in a moment. But here's this right here. Did they know, did the engineers that built this original design know that this was this far off out of skew? We'll take a different color. How about red? Did they know that it was this far out of skew? As you can see, let's put a different color on that one. I don't know if this dark color would work. Yeah. Did they know it was this far out of skew? Look how far it's out. Well, your answer is 100% yes, they did know. And I can prove it to you. Simple as they wrote notes on it. And in the plans, they show that this is where the column should be. They indicated by all the offset drawings like this. This is showing that this is off. These are showing that how much it's off center of the other one by that overlapping like I showed you here. It's just showing it right there. It's showing you how much it's off center from the column next to it. He addressed it on each one. Every one that's off center. This is another one that's pretty off center also. And he addressed it. Down here it's like 8 inches. Up here it's like 6 feet. So this line from here to here, it's 6 feet. This is right here going up and then offset. And so to address that in the original design, he said, look, that's pretty damn offset. How do I handle that? Well, let's go ahead and put this BMA, and here's a BMA here. And let's go ahead and run a beam all the way across. In fact, this is why, because the 1 foot, this is going to be critical, guys, in this whole story I'm telling just now. This is the 1 foot elevation. How do you get 1 foot elevation? A beam. You just put a beam there, and your deck was supposed to be like this. All right, like that. This is 1 foot. This is this. This is the pool area. This is the parking garage area. It's a 1 foot identified right there elevation change. Identified also. I'm trying to grab it. Sorry. For some reason it's not. There we go. Let's move that out of the way. Let's move this one out of the way. Where can I? Here we go. Identified here also. 1 foot. Keep in mind it's the face of the building. That 1 foot, remember I called it Cadillac money back in the day. I said that's, hey, hello, Skeeby. Thanks, Randy, for saying hello to Skeeby. So the 1 foot, remember that's called a Cadillac money because you save money by making it all the same level. As it's identified here, this pool deck was supposed to be 10 foot, 10 inches. And the parking area is supposed to be 11 foot, 10 inches. A difference of, again, 1 foot. It's not a mistake here. This is supposed to be at the wall up here, 2 foot 6 inches. NIST does not identify that lady arrogantly, with her arrogance, I'd say, with her arrogance about they didn't have that in the original plans. Aha, look over here. See these planter boxes over here? They weren't there. They weren't there. They weren't there. But I did a video on that. She needs to reach back no further than then go to Tong, I believe his name is, the engineer that put the tile and sand in the next level of decking over top of this deck. He was the one that I believe added this was added in his rendering, in his rendition, if you will, along with whatever planter boxes, etc. Because he handled the entire deck there, including the pavers, the stamped concrete here. So you don't have to reach back that far. He did it in when? 2000, was it? Or 98? I showed you one of the things. You can find my videos on the Tong. He did it. So stop trying to say that this wasn't part of the original plans. Well, she's being deceptive because she's not saying this was added by an engineer. An engineer that self-certified this, actually, because the municipality did not have the engineer or the want to be inspectors on this. So they made him a special inspector. I mean, you do your engineering license on this and you do your inspection. And well, you sign off on it. So that's what he did. So he certified that all that was done. But she's trying to pretend like they did it right then. And she left off that there were some planter boxes in the original design that were against the back wall that were removed, that were no longer there. I'm sorry, it's over here. That she left that off, that in the original design they were back here, because that would have brought us to this, because those planter boxes were back here, were in this design, the BMA, where the BMA is. And they deceptively are ducking the BMA. I've not found it anywhere, and they're deceptively doing it. This point load testing is a joke, because this deck can't be just point loaded there unless you tell me you got something that's there. You know, somebody came with something to point load it there. It's just a ridiculous point load. It would punch through the concrete anyway. So even their drawing where they show it's pushing down and bending over, they point. I think they use it at one of the arms right here, and they show it just one of the arms, one of the BMAs that go over to, or beam type A, goes over from column to column. They just push down on it. The one NIST guy does in his rendering. And I'm like, where'd you get that load from? It's just pushing down magically here. You know, we've got the collapse, the butterfly coming down here, and it's all integral connected. So all the steel is connected. Let me delete that. All the steel is connected, and so it's pulling, it's tugging. Remember, there's no 1 foot elevation change on the final. This is removed in the final the collapse structure. So they removed the BMA by not going to that drawing. They don't go to the original drawing, as she states. That's a deceptive lie. This is the original drawing. They say that this wasn't part of the original plans, the planter boxes, but she's not stating, the engineer is not stating, the NIST person is not stating that Tong Li put those in there. He's responsible for them. He's the last one on that deck with an engineer to put them there. And then the last engineer to do the inspection was the company was going to do the repairs or supervise them. So back to this. There's a column, and then I state, wow, look at that span from this column, this arrow, all the way to this wall. I mean, that's a huge span. So how do they handle it? They put in a 1 foot elevation change. It's going to be critical. I'm repeating it over and over again, and you'll see in a minute. They put in a 1 elevation change, and they put a beam all the way across 1 foot 1 foot elevation change plus the deck thickness. So this should be 1 foot, right? And then the deck thickness connecting into it would look sort of like they have over here. Here it says 1 foot elevation change. So here's the so up here would be the car area where the cars are. All right, so this is the 1 foot right there. It's the pool deck. This is that 1 foot beam, or greater than 1 foot, because this is 1 foot. And then our deck is what? 6 inches, did they determine? So this is really approximately 1 foot 6, because this is 1 foot step up right here. So then you have to add your deck thickness, and in reality, your beam depth. Let me do a text for you on that. So text, I'm going to do 1 foot dash 6 inches. Okay, give me a second. And I'm going to call it like this. From there. Shit, it's not. Let me put it down here. to there. That little tip out here. And so it's not confusing to you. Let me do this. And maybe it will get confusing, but let's do that. And that color sucks for trying to read behind black ink. So let's go with, yeah, and then let's just beef that up. And same thing there. And I'm just so you can get it into your head. All right. Get it into your head. That's 1'6" because this deck is approximately 6 inches thick. So, and they said it's a 1 foot step up. So you added that thickness to this, and you've got a beam that's about 1 foot 6 inch in height. And that would be this one right here, going from here all the way over at least to there. That's a long span. So how do that long span, you can't have it do that. And then look what happens. They put a BMA between here. Between this column right here and this column right there. This is in the parking side of the structure. And then that sits, this crosses, it sits lower than that. It supports the beam. Or it could be integral like a T, like that. You know, it could be integral that way. But it nevertheless, they intersect, and it acts as a mid-support for this span from here to here. So now your unsupported span is from here to here. And this is a transfer beam to transfer the loads from here to here, over to here to here. It's a transfer beam. And then from here to here again into this transfer beam. So your connections here to here, transfer beam taking over the load depending on how much value they gave it. You can value engineer it to say, well, this can take some less span than our car load, and it's closer to this column. We can make this, you know, instead of 16 inches, we can make it 12. It's got some, you know, logic behind it. This one we can make, you know, we've got to keep the deck the same thickness, so we're going to be stuck with the 1/6. You can't make this one smaller because the deck is approximately 6 inches thick. So this is where you're getting that. Now I'm going to move, so that's that one. Then in the back side where it's a 1 foot step up right here, and this is pool deck here, all over here, all the way around. This you're walking on the pool deck and out to here to the pool. Over here, with a 1 foot step up, is also needs something to make this guy right here. And they even put a BMA from here to here because the step up is back here. See, it's back here. There's the column there. So the end of the, where you see that column, the cars were supposed to stop there. They were supposed to stop there. And there's a planter box there now, if you guys observe. There's a planter box there now, and the cars might still stop right about there, but there is no beam there. There is no beam going across. See the hooks on turns? This has been a 1 foot step up, so it would look like this also. That would have been a 1'6" over to here, right interacting to here. Remember our column. Shit. Move this out of the way. Remember our column is here with the other beam going here. So this one ties into the face of that beam coming across that meets our K column, the one that's the critical one that I've always called out of that outside rectangular array that is the most stressed, and that's on an angle. It's the most stressed because of the car loading, and it's out of bounds for allowable loads. As you can see, it's nowhere near square. It's actually 6. It looks small here, but it's huge. It's 6 foot off. Let's move this out of the way now. I think I have give you enough background data on that. Move it down to the bottom. And let's jump into the, oops, I gotta leave the bottom open to be able to see your comments. Hold on, let me do something with the screen. And move this over here. Hold on, I've got to shrink this differently. Okay, up top, because I can't see your comments are positioned in the wrong place. Okay, now I see you. All right. We're going to start off at 159. I think I have to recycle a page. Sorry, I had to clear my throat. All right, we're going to start off at 159. in 21 seconds. That's almost there. Let's let it key up. Let's see where it's...
Chris Sigora and Ken Hover will then describe...
Okay, he's talking about... I think, yeah, he's using the code check now. I need to go... Maybe I have to go back. I don't know why I said 159. That's 130. Yeah, no, this should be queued up. The important part he's going to mention now, he's going to be talking about using a code check, etc. from... and a software from a 2022 software on a building that collapsed in 2021. Keep in mind that somewhere that they sort of believe that they can somehow make this 2022 software very updated, in other words. This very updated software mimic the building built in 1980. And yet, the steel doesn't exist to be able to add into... Okay, I was watching my camera. That person left from the driveway. Just an update on that. All right, so that they believe they can do that. In other words, they just don't have the brain power to do this without software. The simplicity of what I just showed you, of the rectangular array and the BMA missing. So let's hustle through this. Let's see. He's now going to talk about the code again.
The investigations, testing, and analysis
Hope you can hear
it. And reinforcing steel materials extracted from the physical evidence, in addition to studies on corrosion of reinforcement.
All right, he just said he's going to, as you can see here, they're grabbing the steel, they're going to test it, and now he's going to tell you how he's going to use that material testing
and in results. The third part, Jack Maley and Sissy Nicolaou's presentations will focus on our large-scale laboratory and field testing for structural and geotechnical engineering components. And finally, Sissy and I will discuss our respective geotechnical and structural computational modeling efforts along with their integration.
Here we go.
I will now present some preliminary analysis results from our code checks of the structural design of the CTS building. For the code checks effort, we contracted a structural engineering firm.
Okay, so pay attention. For the code check, they subcontract it to another structural engineer. Listen, and no, I didn't look them up yet.
Cagley and Associates.
Cagley,
that has expertise with a type of flat plate construction similar to that of CTS. The purpose of this effort was to perform checks of the structural design of the superstructure of CTS in accordance with building codes and standards that applied at the time of the original design and construction.
So, the purpose of hiring this guy was to tell about this structure, this part of the structure, not down here. This is usually considered a superstructure in this case. To tell us about the slabs. With using the design, he just states, using the design as intended in 1981 or 1979 code. He makes that clear, but then listen, he gives and he takes.
Construction of the building, as well as checks against current codes and standards.
Now, right there, blow my mind, as well as checks against current codes and standards. Why the hell do you need to know what the current codes and standards are on this building? Why are you comparing it against current codes and standards of the Echo? Somebody says Echo. Son of a bitch. Let me try turning the speaker a little bit towards the mic, and we'll start again. I'm going to back it up by a few seconds because I want you to hear. He says, as well as checking codes against it shouldn't be an echo. Just no more. I should be echoing. It's this feedback thing has got me. Let me turn it down again, and let's try it a little bit softer on the mic. Shit. Sorry, you're gonna have to listen to a minute of it. Let's see. Yeah, it's pretty hard to cue. Fuck. Even though in the background it says 158.52, when I go to cue it, let's try that. Let's see if I can get lucky at 2 minutes is where we need to say it again.
Chris Sigora and Ken Hover will then describe the investigations, testing, and analysis of concrete and reinforcing steel materials extracted from the physical evidence, in addition to studies on corrosion of reinforcement. And in the third part, Jack Maley and Cici Nicolaou's presentations
coming up now
will focus on our large-scale laboratory and field testing for structural and geotechnical engineering components. And finally, Cici and I will discuss our...
Hold on. It's me. Tiffany had to change accounts. YouTube deleting my chats. Okay, here we go.
For respective geotechnical and structural computational
Okay, we're coming up on it. 2 minutes.
Along with their integration. I will now present some preliminary analysis results from our code checks of the structural design of the CTS building.
Code check. Remember, code checks. But he's going to use current code to check that, yet he knows it's a 1977, 1979 code book. And yet he's going to compare it against current code. That serves no purpose against current code. Why are they doing apples to oranges now? That is... I mean, when you build these buildings, guys, building buildings, codes change a lot. And that's why you play a playbook in there. And it says we will follow 1977 to 79 AACI, for example, and these other rules that the municipality agrees to. During your building, if the code updates and it gets better, they can't come back to you and say, we need you to change your plans now to do the updates right now. Even while you're in construction, you go, no, I fall under this code. We're continuing it. This building is already grandfathered in, period. With that said, you don't compare it to current codes. If current day, this still applies. That if I pull a permit, whatever, as soon as that permit is approved, I'm under whatever code that it is. And I don't care if it's an updated code. It happens tomorrow, literally tomorrow. I don't have to follow that. I don't care if it changed whatever. I build still under the old code that we agreed to. So they know that, or they don't, because they're not field engineers. They're just PhD engineers, meaning academic, which could be something as simple as that. Is he thinks they believe of all these engineers, especially that one that they're using the code check with, should be a field engineer. He should know that. We don't have to compare it against current codes. That's academic. That's not what we care about. We care about, did they build, what were the changes, and did they build it like they said they would? And why did they make these changes? This is where it's simple as that. Why did they make these changes? The deck elevation changes. This is critical. The deck elevation changes from 1010 to 11'10". Incidentally, they went up to 11'10", not down to 10'10". If they'd dropped this down by 1 foot, well, water would be coming in from the street, so that would be an issue. But the 11'10", 10 to 10'10", they went up a foot. That made this smaller. That made the structure what I call a plinth beam. Plinth beams aren't usually talked about in the United States, but it's the uppermost beam that stabilized the building, if you will. And this was an elevated building. It was a parking garage underneath of it, guys. Just think of it as simple as that. Remove the walls around the structure, and you can see it's an elevated building on stilts. And what kept this building together on its stilts on this side would be part of this is this 2'6", which held the deck and also held, reinforced the slab here on the first floor only. Because as you get to the second floor, there is no beams going across, or girders, however you like to think of them, going on each outside, I was supposed to say spandrel, each outside of the glass doors. It was just a deck thickness only. So this intent of this is to hold the deck. The deck stops here, and it seals off this 2'6". I think the intent was that it was 2'6" was to act like a plinth beam to make this more rigid by the deck, to make it stronger, to also stop any gaps from water going behind it, because you could make it the deck there and then elevate the building just a touch more to make the floor elevations the same. But this was the Cadillac money. It'd say, get rid of this shit. Don't move the beams over. Don't add extra beams. The reinforcement did change, and this is where it's critical also, that when they remove these beams, these BMAs, the Cadillac money I call it, Cadillac money for you guys that just coming into the video means that you can remove these and make this shorter. That was equivalent, all that concrete, that was equivalent to a Cadillac. And all the work too, buying a brand new Cadillac back then. So the Cadillac money, you raise it up, and I'll prove the raise up. It's so critical, guys, that they're going to tell us. You're going to see how, you're going to know exactly when they raised it up, when this design change happened. They reveal it, but they don't even know they reveal it because these are amateur hours. These are, no offense to the PhDs that follow me, they're just PhDs, they're academic. They don't get the significance of their own data. So this, her talking about the planter boxes in the next rendering of the plans, she's not talking about the extra steel that changed over here. See, when they removed these, they added like 2 pieces of extra steel. I'm laughing because it's a joke, all right? And they added 2 pieces of extra steel going this way, and I think maybe 1 this way or 2 this way. It was very insignificant. I did a video on that. I'm not going to show the image of that one here. Okay, let me pull that back. So when I say they added extra steel, so this is number 4 bar, which is 1/2-inch rebar, and it's 11 of them. And so it's stating, the way I read it, from the center of this support to the center of this column is you add 11 pieces of rebar. I think they changed it to 13 pieces. And then over here they did something over here. This is 13 number 4s. No, it was, I think in here, yeah. And here they added some more to change the rebar amount. It was very small. It was like 2 more pieces, but they don't line up. But here we go. Now this is where he's going to again talk about referencing different codes.
For the code checks effort, we contracted a structural engineering firm, Cagley and Associates, that has expertise with the type of flat plate construction similar to that of CTS.
Okay, let's stop that. So they said they have expertise in the type of slab construction as CTS. So Cagley and Associates must be around since 1979, because if you can't do this same slab anymore, because they're going to say the slab didn't meet criteria because of the placement over the heads, etc., then is Cagley and Associates, are they placing defective slabs? Is this what this? Did this guy just imply that Cagley and Associates puts defective structures up? Now, they should have no expertise in putting a slab up like this because the slab is not designed correctly or installed correctly. So you should only have, a theoretical knowledge and also a physical knowledge, seeing the building collapse, what's taking place. But he should have no expertise in installing these, because that means that he's, like that guy, defective. Here we go. So, their wording counts.
The purpose of this effort was to perform checks of the structural design of the superstructure of CTS in accordance with building codes and standards that applied at the time of the original design and construction of the building.
Right, that's it. Now you should have just left it at that, but he does the "and" part.
As well as checks against current codes and standards.
Which is ridiculous. You don't do that.
The original design checks were carried out in accordance with the 1979 version of the South Florida Building Code and the 1977 version of the American Concrete Institute Standard 318 for Reinforced Concrete Design, or ACI 318.
So that's the original design. The ACI, American Concrete Institute, they used, and they put it in the plan saying they'll be using the ACI 1977. That's the book I literally own today. I showed it to you. I did a video on it. Literally own it. I literally found that they had issues with rectangular array back then, which is right here. They talk about the amount you could be off by, like 10% total. And since it's a continuous slab, I would say that they're compounding, which is not made clear in the book, that it's compounding. It says you can only be off by 10%. This is huge. This is off by 50%, and depending on how you do the angle, it can be off by less. But I did the angle from here to here where the column's supposed to be, and that was like 50 degrees. I'm sorry, 10 degrees you can be off. And And right, no, 10%. Ah, shit. I think it's 10 degrees. You can't be off more than 10 degrees. Ah, fuck it. It's in one of my videos, all right? You got to find that one. I got to pull up the book. Let's go.
The original code check used design practices prevalent at the time of design using simplified methods of analysis typical of 2D models.
Oh, just so you know, I've got the book in front of me. I'm trying to find the that real quickly, the rectangular array. And it's not like you can search it. I'll highlight it for you guys. I'll flip through this as this plays, and I'll read off my notes as he goes. This part we let go to, okay, next page. Our next point is at 207. No, we'll let him play this a little bit. And at 207, James Harris identified. Okay.
The current code checks were based on the 2022 version of the American Society of Civil Engineers.
The current code checks were based on 2022. The building collapsed in 2021. And they're now going to compare it against current code checks in 2022. So this is just, is this madness? Is this gaslighting beyond craziness that the NIST is doing an evaluation of a building that collapsed in 2021 and comparing it against code checks of 2022? 2022 didn't even exist when this building collapsed. And they're now going to compare it against code checks of 2022. You heard him say it.
Engineer Standard 7 and then the 2019 version of ACI 318.
And
current code checks.
And 2019 of ACI. Again, the building was built in 1980-81. And they're using code checks from, you heard what he said. Let me see if I can back it up just a touch.
The current code checks were based on the 2022 version of the American Society of Civil Engineers Standard 7 and then the 2019 version of ACI 318. The current code checks relied on state-of-the-art design tools employing three-dimensional finite element analysis.
So they're using current code checks, finite element program. And then he's going to see how he can somehow devalue this and make it match up.
Software, including ETABs for the entire building and ETAB for the floor systems, as you can see on the figure on the right side of the slide. To measure the compliance of Champlain Tower South with structural codes and standards, we use structural analyses to calculate demand to capacity ratios, also known as DCRs, which is a strength required by the codes prescribed.
All right, so now we're going to go to 2 minutes and 7 seconds, 7 minutes rather. And I'm going to go as 206.51 and see if it creeps up to it. At this point, 80%, it's a joke, I say, because this guy, their expert right here, is going to he's going to gaslight, he's going to lie about this concrete. And I've been holding out for something for some time. And I'm going to tell it to you now that this 8% roll of concrete, and it's too clustered, it's too bad. Now, it depends on the aggregate you're using, how good you are with installing it, and the bond strength you can get out of it. Now, how can I say that? Well, because if you look up a building that's being demoed in Las Vegas from the 1930s, this building, I mean, it was clustered with steel way beyond 8%. They had to drill and put, it was major work because this building had so much rebar in it, way beyond what they use now, this 8% trash junk. And it's a demolition company that he had to spend $250 million basically to weaken the structure, to weaken it. By their theory, the more steel you add, the weaker a building gets. It's not, and that's not true. This 1930 structure, they had to blow it up, and it didn't go down like, oh, you know what? They got so much steel in here. They got 20% steel in here as opposed to 8% per volume of the concrete that you're working on, the shape of it. And so, it's going to go down easier. It's a contrary to what you would think, right? So you think the more steel, it would be harder to go down. Well, it turns out that's true. It's literally true. Using a 1930s demo building of one of the, I think it's 30s building it was one of those Bugsy Malone type buildings, one of those guys that owned it. They caught hell. I watched the whole entire documentary on the website of one of the demo companies about how they had to re-drill and more dynamite and re-drill and more dynamite. They did not make the structure weaker at having all this steel. That it made them catch hell trying to make the structure weaker to be able to implode it. And so again, this lie about 8% is just a lie. Now they're going to talk about pulling potential test of rebar. Remember I showed the black steel. One guy does ask him about the steel, but he doesn't know to ask about black steel, and the NIST doesn't know to identify it. But nevertheless, they don't have the deformation. They give up. The deformation is the shape of the rebar, that the lines, the grip, the rebar. You guys know I've shown you what it looks like. The shape of that steel gives it, once the concrete locks around it. So when you make a cake, all right, let's do the cake analogy that a lot of engineers like. I can stick a piece of rebar in and out of it while it's wet. In and out all day long, right? It's wet still. If I put the rebar inside the cake and then I bake it and it cooks. Now when I go pull the rebar, it's going to pull part of the cake, isn't it? It's going to pull the cake with it. Well, that's the rebar pull-out strength. And that tells you how stable and strong everything will be. They didn't do one of these tests. Not one rebar pull-out test have they done that I've found that since I've been watching this content. They're doing things separately. Let's test the concrete separate. Let's test the rebar separate. And then let's use a code book from 2022 and software from 2019 or 2022 and a guy it's ridiculous. It's just ridiculous. It's as simple as what it is, guys. They didn't follow the original plans. The people didn't do the repairs in a timely manner. They had problems when the building was first built in the 80s because they had to do the repair down, I think it's right down the center here. And that shows you where the weakness was. They reduced the load capacity of the deck when they did this crazy ass thing here out of being square. And this puts the greatest stress out here on this column here, the one that revealed itself 40 years later in a cracked planter box that the guy identified as branches. And if you remember, Josh was all down with that too. And I said, no, that's a rotation in the deck out here and over here. That's your rotation as identified like that. And it's more over here and not on this side. And I think they actually identify it more on this side. But it's more over here. And look at that. There's a butterfly. It's more on this side. This is the part that's set down. Not here, because this image shows pretty much flat. As it does that, it does give a fracture in the mid part of the box further down. That was because they sent out an engineer that didn't know what he was doing. Didn't know that, oh shit. And also, the craziest thing of all is this company that did this survey of this and was going to do the repair schedule, they're actually a pretty damn good company for doing garage repairs. So I think they were bullied into, and I wish they would have defended themselves instead of just paying up. I think they were bullied into, I don't think they were dumb enough not to support the structure. I think they were bullied into, for parking reasons, not to demand that propping go in right then, because they showed enough structural problems and comments that would have said propping is needed immediately, supporting is needed immediately. So I think they were, and it's the way it is in real life, that they were bullied in, look, you want to, we need the garages still. We can't go out in a car. We need them. Do you think you can get by until, June? And they said, oh, okay, yeah, I think we can. But then COVID hit, and they never revisited this is what I theorized, revisited this saying, hey, look, you know what? I played along until June, but, it's now 2 years. Now COVID hit, we need to support that deck. You need to get out of the garages somehow. That had a major, I think it was a major pressure from the condo association, whoever hired and whoever was talking to the engineer, to stop him from supporting this. And I really think that because another garage down there, another building down there, 1 or 2 years before, he put supports in. He knew to put supports in. He put not one support in here, this engineer, this company. And he didn't demand one support right then. But yet when they were doing the repairs, he was demanding supports. I'm like, okay, let's go.
Building a code history project. Fahim just described several places where structural analysis indicates that the design of the tower did not meet the requirements of the building code at the time. And we've previously shown the same was true of the slab at the pool deck. I'm going to describe a few instances where the details of the design and the construction did not meet building code requirements or common standards of practice at the time. The requirements illustrated have not really changed much between that time and today.
Okay, just so you know where he's going to go. He says they have not changed that much. 9.75% vertical reinforcement in column at this splice versus 8%. So this guy's bitching over 1.75%, meaning that he did the calculations of this versus the column, and he's saying it's 9.75%. Well, and he's going to say this weakened it. Well, and he's going to show microscopic. Well, if you're down to trying to prove to me it's microscopically wrong, well then we're in the part where it's fatigue. A future crack may develop from this microscopic level. Not at the if you can't show me a visual crack with your eyes, then we're microscopically we're at points where you're not going to be searching for it typically in anything like that. And as you look at this and use your common sense. This building collapsed. They threw this around in a truck with an excavator, drove it down the road, vibrating it to hell. It was never intended to be driven down the road and vibrated. But yet, all of that behavior, beating it up, I don't see the cracks. All right, this steel. Okay, so you see two pieces of steel here. This is the upper column and the lower column bypassing of steel, touching each other. And he's going to talk about swelling and it can shrink and etc. Don't let your lying eyes tell you the truth. There's no fucking break here. There is no cracks here or swelling. This is still bonded pretty damn great. And these images, as far as this goes, this might be the black steel, or since you didn't zoom in enough, how is this made? All right, how is this done? Because I can't tell whether it's cut with a torch or what the fuck's going on, because this almost looks corrugated. Look how it goes in and out, in and out. And so looking corrugated like that, this makes me think that how do you get corrugation in concrete, right, in a column? This is probably where they took a core sample from, maybe, and they cored in here. But this is weird. They cut across it. This part has got me. This shape. I wish they would explain how this sample was developed, because this has nothing to do with that building. Nobody's laying down form work like this in a steel flat like that. This has somehow been cut with a torch, not a saw. Up here, I don't know what's going on here, but because I can't get in closer with it. But it's real weird, this piece. And he says worst case at another column is 12.2%. Now, when I get around to it, I'll show you that building in Vegas. So like 3 years old that I investigated that, and for data, and it's well over 12.2%. This building collapsed, and this shit's not broken apart. This is tight. This is tight. He's also going to state that the steel was at the surface of the had no cover. So this is the steel. This is the cover. This is the steel. That's the cover. Look at the triangulation of it. Now over here, we can't see over here beyond this because he's not showing it to us. But you can bet the column wasn't shaped like that. So there was more cover with this. This is, if I'm going to extrapolate, I'm going to say this much cover was beyond this part. But now he's going to gaslight us and tell us some bullshit. I think this might be the inside surface area don't be so quick to judge because of lighting. Whether this is a cover put on top of this concrete. Don't be so quick to do that. It looks about the same here. So, and this looks like the same concrete here. So we might be getting lighting screwed by the lighting in the camera photography.
The photo on the upper left is the cut end of a column that's supported.
He said the cut end. Yeah, how the fuck was that cut? It's all irregular everywhere. So calling it the cut end is what? Are you shitting me? What did they cut it with? I don't know how you duplicate this. I get this part. You can use a hole saw. Let me see comments. Great summary. Thanks, chicks. And brilliant analysis. Thank you. Yeah, I'll use to call you dog. Dog. So again, this looks like corrugation, right? Like it's up and down like this, like that. But it could be flat, and I could be, just seeing ghosts, as I call it. Now that the shadow's there, and the shadow's there, and he called it the cut end. Cut with what? Cut with what? A plasma cutter?
Supported the tower. And it is at a place where the dowels coming out of the foundation are lapped with the main reinforcement in the column.
Here's the lap he's talking about. He's talking fast. I know you guys might not know what he's talking about. This is the lapping where the column above has to match the column below when you're doing this deck. Yeah, give me a second to pull up an image for you. Give me 1 second to pull an image up. This is terrible. There, his imagery is terrible. I'll give you a better image. Let me look up something here. Let me see something here. Images. I'm pulling up something to the right. All right, let me just drag this over to you for a minute. Okay, as you see here, this is the lapping part. Now, if you were to cut this, here, make sure you can see. I got to look at my other screen here. Yeah, if you were to cut this, break this apart and cut it across, this is a coupling, incidentally. That's another way to connect rebar coupling, and this is just wire tie rebar. If you were to cut it here and look down the top of it, like it would look like this. That's big rebar. So this might be lapping here. This is just, kind of. It looks like 3 here. I don't know if there's something, but that's his bullet for doing his LiDAR. They do this scanning, so that's one of their bullet markers. So I can't work with that. But here is a lap. We might use that one. This is one. Let's use. Oh, that's weld. That's welded, I think. This is lapping. So you can bend it, and so it stays in line. See this rebar? If I would do a straight line, it would go straight down there. And this is so it stays in line, the rebar reinforcement. But some people just do it like this. And you just offset by 1/2 inch. Right there, well, the thickness of the rebar. This one has got a little bigger deformation to it when you do this long stagger and this one. It's sort of, I like the lap that's like this. Now, with that said, lapping length doesn't work, all right, at all. The lapping length, if it worked, it wouldn't matter where we put it, all right? I love that. I love to reveal that to engineers. If lapping length worked, 50 times diameter, whatever it may be, then we could put it anywhere. It wouldn't be, oh, you can't lap in the tension area because it will pull apart easier. Well, I thought lapping length worked. It won't pull apart easier. So if lapping length worked, then we could put it anywhere. But it does not work. It just bond. The concrete's doing the bonding. Let me get rid of that tab. So it does work, but if it really worked for your engineering calculations, you could put it anywhere you want, but it doesn't. All right, it is a weaker section. With that said, look at the cracks around here. Can you see them? I don't. Let's listen to the rest of his. I have him queued up for up to 2:10. So yeah, we got another 3 minutes of him.
Column. There was, and it.
Somebody said cut with a water jet. Dog said that. I don't know what they cut that, man. It looks like a damn chisel. I don't know.
Is a code requirement that the maximum area of longitudinal reinforcement in the column not exceed 8% of the gross area of the column. Not all engineers interpreted that requirement to apply at lap splice regions, but it does.
See, make note that he said that. Remember, not all engineers said it applies at lap splice regions, so he says it does. So he insists that it does. He should show us in the code, and I have the book in front of me if you listen to it. It does not specify that you do a deduction, that you take away this. Your splice reduces your let's do this. If it applies, that means when you do the splice, you're going to reduce your steel at this section that you want to reinforce. So right here, if using his logic, which is wrong to use, you'd have to reduce your steel. So you'd have 8% here, 8% here, but because you have splicing up to here, you'd have to now reduce your steel size. So your 7/8 steel, to make it work, you got to now reduce it to 5/8 up to here, and all throughout your splicing to maintain that you vigorously stay at 8%, or you might get cited by a asshat like this saying you're at 9.75%. No. And literally, as we're looking at it 40 years later, it works. So if they want long-term testing and see if it really works to have the excess amount of steel up to 12.2%, you look at this sample. It was involved in a collapse, and yet it didn't go all to hell. It was not all evenly spaced, as he states, but yet it still stayed together. The failure is not of the columns, it's of the deck integration into the columns. The slabs breaking free at the columns. As we know, 611, remember 611, that's the lady who came out, God woke her up, and she went out to feel her strong wind. She heard the winds, and whatever way it may have been, she thought, it's the door. The slider door must be open. I must not have closed it. So she goes to close the door, and she cannot close the sliding door. It's 611. Remember, 711 is above them. That's where the ring camera is with the materials ejecting down. 711 is below 611. That means the wall at the door where she was trying to slide it close was deflected outwards towards us, as it wouldn't be in. That would make it shifting the building inwards. It would be out towards us, towards the pool deck, and deformed. So much so that her door couldn't close. She made note of that way before 7-Eleven. She does knows. She could not close the door. She looked to the right. And looking to the right, she noticed approximately, she describes, 2-finger gap at the wall there. That's that. Let me pull it up. 2-finger gap at the wall. So this is 111 from here to here. All right, this is 111 from here to here, 111. The unit 111. Out to the hallway. All right. So right here is where it's a brick KLM. Okay, I'm putting the door here. So let's put the door here. The slider's right about there. I just remember the first floor, the pool deck of 111 had it there too. Here's a doorway. She runs out and close the door. She can't close the door here. And why can't she close it? Because it's at a square. Now, she looks to the right. She described herself looking to the right. And then we want to put her over here and looking at this. But the door could slide. This could be the slider on this side, and she could be looking there. I don't know which slider is. I don't care. Not yet. Not yet. I just sort of my Columbo move on you. I just gave it to you a bit. And as you look at that crack in the wall, the separation, she decides time to take flight. That she doesn't say it's vibrating. The building calmed down now. It's no longer moving. It stopped moving. That's after this collapse here. It already went up to the 6th floor at least, and I believe the 7th floor also. And she never talks about being present and the building shaking. Remember, 7th floor shakes. When she wakes up, God, she thinks wakes her up. She's in just bed over here, right? I think the bed's there. So when she wakes up, reality, the building shook, but her amygdala picked up that something's not right. It woke her up. Her amygdala went back in time and said, hey, maybe it's the door. You left the door open. Remember, the amygdala never sleeps, but the amygdala can't tell, what to process what your knowledge is. So she goes out to the door to close the door. When she gets there, the door, it won't close. At that point, she notices there's a crack up a wall, using her right hand, 2 fingers up, 2-finger gap. She then goes back this way. Blows out a candle, gets keys, changes it from a wardrobe to her dress. She knows she has to leave, she says. She does all of this. Closes the door to her apartment. Remember, this door wouldn't close. This door would close. She never talks about this door not closing or opening. So she was able, that means the engulfment of this pull that fucked with the face wall. And I did a video on that showing how the reinforcement is only on, like this in this column. At the face columns, this is the face column here. It's only around 3 sections of it at some places. Where there's a deck, it does go around just a little bit more. You get a little more value out of that. But I'm trying to move the damn thing. And I have no idea what I just moved. All right, so this just goes to there. This thing is acting, it's not letting me play. So here we go. So you're on the face columns where they're just faced like that. There's very little interaction. Down here on the first level, there's a step out here. There's steps here, guys. There's some concrete backing that up a bit. Works against us also. The next floor up, there may be a deck or no deck. There's random on how these decks are. Wherever there's a deck, add a column. You get to add a little value. Let me add a little horseshoe here. Horseshoe, and this will be a deck. Wherever there is. So there's at some deck, some of these columns have a deck. It's a deck around them. All right, let's maybe make it bigger. A deck around them. But some of them, they don't go all the way over. So that column there, for example, would have no deck around it on the first floor, second floor either, I believe. But then as you go up, it now has a deck where she comes out of the door and she can go over to like there. So this gets some reinforcement, but this gets shit all. It gets that 3-faced like that. 1, 2, 3. So it's weak. As this rattles, it tugs on the building and it tugs on the columns because it's connected. It's connected. And when it tugs on there, 611 states that she could not do that. Now, she missed a powder deal because she was asleep. She didn't observe that on the floor. She had candle light, apparently. She never talked about turning lights on. But 711, while she's asleep, when the 711 rattles, the building shakes. I believe the building came to a pause, and then she was able to take that view, and she's at 611 right below it. She's sharing the same wall, the column, as 711, and she's in that same stack, if you will. It goes all the way up. That she takes that time to leave. When she leaves, and we see the video of the ring camera start again, that's when she's between the 4th and 6th floor, she states. Now, NIST doesn't talk about her eyewitness account or her positions, etc. It's so critical. That means when the ring camera picks up and we see it collapsing again, that the ring camera also must have calmed down, meaning it no longer had any motion alert. That initially had the powder coming out, and we observe it like it's all one activity with a short break between the two. I think the ring camera had a long break between it. Otherwise, the building rattled. This is the playing devil's advocate. The building rattled, wakes her up. She noticed a big crack at 611, but ring camera doesn't pick up this huge-ass crack that she can't close the door, but it picks up after she gets here. No, I don't think so. I think the powder ejection, everything you see from the debris, from the original rattle of the face of the building, from 711, 611 to below, 711's view, woke her up. Building calmed down. She goes to close the door. Nothing. She doesn't speak about a building collapsing or anything else. But she gets worried. She leaves. Makes it there. And that's when the building continues to collapse. All right. Because it's using a NIST camera and overlapping her room below it, there's no way she would have made it out with the timeline she gave. So the powder starts on the the ring camera, and then we see that very short break, and then the collapse happen. Well, there's no way she could have at 6:11. The powder that line the timeline with that cracking happening. She walks out. Does all that, comes back, blows out candles, changes her clothes, grabs the keys, closes the door, and walks down here and goes there. There's no time for that. So the ring camera must be on a motion sensor that was picked up twice. That we're looking at 2 videos combined is 1. Again, there's no fucking way that there's no one that could do that with that timeline. As you see those powder happen, you wake up from here, walk out to here, do that, change keys and all. It's physically impossible. Physics, you can't do it. If you did your fastest race ever, you could not do it. If you were young and practiced this 30 times, you could never beat that second collapse in the ring camera when it happens, when we then see the second version of the collapse happen. So there must be a break in that ring camera that they're not revealing to us. No one could, you could practice it, like I said, all you want. You could never wake up and do what she did, all those steps, and be out of the building in time if they were both correlating together without a delay. Let's go back to this now. Again, we have to take this to 2:17, 2:19. Shit, you got to take this 12 minutes, guys. Let's listen. He gives a lot of shit I got to chew up, and I want to make it to 2:30. Shit, I apologize. I thought this was going to be a short video.
It does. One of the reasons for this is to prevent interference between the reinforcing bars and the large aggregates in the concrete, which...
Okay, to stop interference. So there's a rule based on aggregate size, how much space you must have, so the aggregates can get in there along with the paste, the concrete, the mix, the matrix, sand, everything, so it can bond. And so you can't have this like half-inch apart, for example, and then use 3/4 inch aggregate, because no concrete's going to get there, but no stone will get in there to make the matrix up, but you'll get paste. And this is what they could have done to prove it. They could have said, we took apart this and we saw this is mostly paste. But then again, I would say, who gives a fuck? It's still together. It worked. It fell down. Whatever story this came from, whatever floor this came from, it made it through it. And as you saw, I call them sausage links. They were laying all over the ground out there. They were all together. They didn't buckle. And yet they're applying some buckle behavior there. Now, first floor is another game, but let's go. Because of the reduction, the deck being tied to it.
Which can lead to excessive voids in the concrete.
Which can lead to excessive voids. That's the theoretical talking about it, and that's what you do talk about. But there are no excessive voids here. This shit looks tight.
The image at the bottom center of the slide is taken from the drawings for the original construction.
Aha! Now, he made a mistake of taking the image so we can pull this in now. The drawings. So you brought the drawings in, and that if you bring the drawings in, we get to bring all these drawings in. All right? We get to bring in the BMA. And now he's going to get pissy about the 3/4 inch cover on the deck.
And it defines the minimum clear cover between the surface of the slab and the reinforcing steel in that slab. Given that the balcony is exposed to weather, the reinforcement in the projecting slab should have had 1 1/2 inches of clear cover, and this shows that it had 3/4. While some interpret that the protection of the top surface with a waterproof membrane would allow 3/4 inch cover here, neither the architectural nor the structural drawings specify a membrane on the balcony slabs. The drawing at the right show.
Hold on, he jumped over it. So now he should be able to go pull up those balconies and show us where this failed, so it was so thin that it spalled, that it broke through, and everything else. No, he can't, because we see those balcony slabs on the ground every fucking where, and they're all together, and they had to drill jackhammers through them to be able to lift them up. The angled slabs, the balcony slabs. So this, whatever they did, it still worked. So. To now say it's shit is wrong. Even in you're saying about this cover, the concrete cover being too thin at the top would usually indicate itself by, if we think of that building that I was assisting with, the one out in Iowa, with the pool, the balconies there. Remember how you could see the rebar? Well, that had very thin cover on it. This obviously had enough cover. And he's just saying it doesn't have the cover. But he's not presenting us, this is in a drawing, but he's not presenting us the real field image. So this is smoke and mirrors. It's saying this says this, and that's wrong, he's saying. Just saying it's wrong, blatantly wrong, because it should be 1.5 inches. But then he's not showing us where it was a problem, like showing us a cutaway view like he shows here. He's not saying, now look at the image to the right, and there it is. So this is just a narrative, what, $6 million narrative that people like me are going to get. I'll never get traction, as you know. YouTube now recommends my channel to pornography, so let's go ahead and help them out. Please come join me if you're watching porn. This is concrete porn, and we want you to watch this. So to the YouTube person or is supervising my shadow ban, you are a cocksucker.
Shows the slab column joint at the lobby level along the south edge of the tower at grid lines K through M. At these locations, there is a beam, type A, extending from...
Oh, at these locations, K, L, and M, there's a beam, type A. Beam type A. At these locations, K, L, and M. Okay, let's go and get rid of this shit. This is K. This is L. All right? Sorry. This is M. So when he talks about it, this is, let's get rid of that. And this is K. All right? That's K, that's L, and that's M. He talks shitty about KLM, and he says that a beam type A is what he says there. All right, the beam type BMA, right? He says beam type A. This drawing never indicates it's supposed to be a beam type A. It says BMA. He's forcing it to beam type A because beam type A in the drawings actually tell you the measurements of each one. And it says, it will tell you that it has a number next to it and it tells you what size the beam is supposed to be. These are never fucking identified to us. These BMAs, they are never identified anywhere in the measurements. This right here doesn't have like a number 11 on the chart. It'll say like number 11. It never gets identified to us. I'm trying to see if I can see it up in the background. If the yeah, see this? BM 35. Beam 35. Now he just called it beam type A. All right, so BMA, I told you NIST has a BMA. He's saying it's a beam type A. He cannot state that. They never make it clear. They talk about a beam type A, but they also talk about a BMA. And I told you a BMA exists under, where'd you go? Right here. You pull it up. Oh, fuck me. Hold on. Great, I screwed up. Let's look at that for a second. That's the rectangular array image I did a long time ago, showing how far bound. It's 50 degrees here, 14.6 degrees if you count from here. This one's 5.8 degrees. Two-way slate failure design greater than 10%, not more than 20% total combined in rectangular array. That's what it states in the code. This is what I put in this drawing picture here. I found it now. Steel does not run, and this is skewed steel. It does not run, so it's all the loads comply torque because the steel runs this direction. You can see how far off that K column is right here. It's 6 feet off. This one is 3'6" offset. They're fucking huge. This one over here, and this is the one that's over by KL. So this is K, L, and M. That's 6 feet off. This one over here is 6 feet up and 3'6" off. So 6 feet up, 3'6" off, and when you do this angle, okay, 50 degrees, or if you come from there, it's 14 degrees, 14.6. But it says, and not more than 20% total. Remember, this is the same guy that says people read the code wrong and they misunderstand it. He says it's a total of 8% period, combined. Well, in that case, I'm going to use your definition and say it's combined also. I lost my damn my BMA picture thing for you guys. Let me find it. the NIST one that I had in the beginning of the video. Let me pull it up again over here. Let me see. Oh shit! I think I'm gonna move it. Once I do that, I'm gonna change this image. Let me put that out of sight. Hold on. Over here. Let me search it. Where are you, baby? Found it. Okay. So this is NIST definition. This is literally from a NIST document, page 30 of 110. It says the connection details vary from post-tensioning with 2 post-tensioning bars. BMA. That's what they literally called it. So that you got to go back in time. And this is, I found this report back pre-1977, and they reference a BMA, not beam type A. And it's called, and if you use post-tensioning with 2 post-tensioning bars, not bars, not cable, all right, not rope, not wire rope. This is cable, and if you do that, it's called a BMA. A connection using 4-threaded bars is called a BMB. A composite connection, a BMC, consists of a CIP topping and a precast beam connected with post-tension bars. A welded connection is a BMD. A bolted connection is a BME. And down here, right here, if you use 4-threaded bars into couplers anchored in a column, you're using a BMF. And there's a BMG, a tapered threaded splice. So a BMB, a BMA existed, and he just said it's a beam type A, where the drawings specifically state BMA. I know it's not actually semantics. It's because a BMA exists. If a BMA didn't exist, it would only be beam type A then. All right, and somehow the architect and engineer wrote BMA here, and up here they wrote beam BM35. Why would they put type A there? Type A is a different one. I think it was, if I remember right, maybe it was like this. No, that's a drop slab detail. It was, yeah. It was, I'd have to find it. But I'm showing that BMA exists, and this is a NIST document right here that you're looking at. It literally is a NIST document. So if you're trying to find this document, I think he would just do, yeah, just get hold of me, fuck it. And tell me your interest, and if it's worth my energy, I'll get it to you.
From the tower column to the adjacent column to the south that supports only the pool deck. The function of the beam is to support an intermediate step in the slab between the tower wall and the pool deck.
So he's saying the function of the beam. And concrete, 4,000 psi concrete in slab and 6,000 psi in column. Lack of ties within joints. Okay, so he's saying lack of ties. What the hell does he mean? All right, stirrups are what we're talking about, because the stirrup system here, it's a different detail. Besides that, they stay together except for, let me get it for you. That would be, oh yeah. So we'll come back to this tab. That would be right here. This is K. This is the one with the head on top of it. This is white as below, so you could see this was below the parking garage area. If you looked up, if you were in the parking garage area and you looked up, you would see white, and there's the white. This is literally K, and then L is somewhere over here, probably twisted and broke off with all this material fell along with M. This out here is the planter box. They're going to be described as 3 foot. And right on top of the planter box is grass or planting material. The column is still standing proud. We know that later when they finally pull away part of this deck. Interesting enough, this fracture here is what I talked about a long time ago. Right here, it's kind of mapping this direction back to here. And then there's another one over here, and I can't see it here, but I talk about it. It must be in another photograph. I did some overlay stuff like this to pull it up, and I show that your planter boxes are over top of columns again. These planters here, these 3 foot, as described as 3 foot by NIST personnel. And this video is marked private, but I'll give you a quick cursor. What the hell happened to it? Yeah, so there's your deck, your PSIs. This is where they were going to support it. Strong removal column face, right. Let's see what else I got here. I'm just going to try to scheme. Okay, here we go. So there is the grass on top of the column. This column didn't, and they didn't even strip it down yet. And I put this up 2 years ago, this video, and 1.1 thousand people got to see it. This is the top of it, the grass head. All right, the top of the grassy knoll right there. There's the planter box right here. It's still on top of the deck. Now, when they do their model, we're going to talk about, they're going to make this damn little sample, and they're going to push down on one section of it, but the deck behaved as one. The deck is all together. They're like, we don't care what your lying eyes see. We don't care what your lying eyes see. The deck separated. And let's get you to the lying eyes thing again. The deck behaved as one. It's not this part of the deck fell down and then that fell down. Save this crack here. See, this might be my part of my deviation, but then the problem I'm having is that if this fell down over to here, and then over here is a section over to there, and we have the guy coming out, the near son coming out, or the near man, he comes out, looks over here, and he notices the butterfly and this, but he never talks about his pool deck being gone. That implies that his porch being gone, and saying, what the fuck, I look down at my feet and it's gone. He talks about this distance being down. So maybe this had some secondary collapse, and this is the indicator of this crack. Maybe it bent like that over to there, the primary collapse, along with the cars going under, and then the secondary collapse was this coming down, this section here, all the remainder. And when the secondary collapse came, that accelerated the building collapse. Because remember, we also have Cassandra Billadu Stratton coming out, and she's mentioning a sinkhole. She's not talking about the whole deck being down, all down. She says like the pool is sunken in or whatever. She's describing over there also. So, and they don't talk about her, incidentally. And she describes the sinkhole. At least I don't think they do. In detail, like I'm talking. And the sinkhole, she describes it as. Not as everything's down right around me, this is all collapsed. No. She doesn't talk about that. And the planter boxes are down, and this is punched around here. No, she doesn't talk about all that. She talks about this. So I believe that's the primary, and then secondary is from here over. But NIST is going to they're doing a sample, and they're just going to press right here on the planter box. No, and they're going to remove this. This doesn't even exist in their model, as you'll see. I wanted to show you. So the drape, you can see the drapes here. You know, it's continuous, all tied together, pulling together. There's no break there. There's no break there. There's a punch around there. There's a punch around there. There's no break. The only bend is here, and there's some cars underneath there. There's a bend here, and then I've got that fracture I talk about, which is right about here, going over to here. And this planter box is plumb. It's flat, level with the deck. See this one over here? Just look at this one. It's about flat. But they're going to have it going down like this first. If it does that, how the fuck does it recover and make itself flat? The bushes are standing proud, straight up and down. No, I think it pulled and tugged and tore itself from the building and fell flat. And then we get our video camera lady, and then we get our secondary failure. There's the sausages. There's all the columns. These are the columns that they're talking about couldn't hold together because they're lacking. They put too much steel in it. Well, they fell over 12 stories, and they're all together. And now you're going to try to tell me a story that they didn't fall over. I already went over the drain system and everything else in this video. And there's the planter box, a closer view of it. It's flat. These are the steps. Flat. Over here is there's a palm tree that's also standing proud, straight up and down. I don't know if it's in this video. Let's see if I can show it to you. But K is over here, right there. That's K, right there, right in front of my mouse. That's K, punched through the floor. So K, yeah, the head came off of it, and I don't know which way it went, this way, that way. I can't, you know, if I had closer images, I'd be able to tell you. We'd be able to find it. So there's K here. That's literally K. There's the one that punched through the deck, the one they had the early warning signal of. But there it is. But part of this, here to here, from here to here, is where the BMA was it's supposed to be a BMA connected to hold the over to here. Initially, it's supposed to be over to here per the designs. This is K. That's the one I'm showing you. Per the designs, it was supposed to go all the way over. But now it's a BMA from here to here, and then another cross beam going from here to here, and then a beam from here to here, one from here to here, and then this is 11 foot out. Remember 7-11, it's real easy to remember. 7 foot step up, 7 foot out here, 11 foot out here, and 11 inches, 1 foot 11 inches here, step up. But it was 12 foot 9 supposedly. It's the original design, remember? So that's now changed. It dropped the foot off, so now it's 11 inches. This is the original design that he's now referencing. But he's ignoring that and saying, we're going to talk about, and I did this in February 2022, guys, way ahead. I talked about planet box and car loading at K. I talked about K way over here. All right, and I think I pushed it over by one in there. Let's find it here. Go.
The light gray shading on this figure represents slab concrete, and the blue represents the column concrete, which is specified to be 50% stronger than the slab concrete. The building code allows for transmission of column load through weaker concrete and floor systems under various conditions, but none of...
Hold on. Remember what you said. So it's a percentage they allow. He's not saying how much, which is, I mean, why not just say the percentage? It's a percentage of that you're allowed to be off. And so what he's saying is that there's a floor going in here. So the column's done, the floor coming over here, floor coming over here, but in reality, we see it as a beam, all right, as a beam. 2'6" initially, reduced down to 1'6" after they did the deck elevation. So right there, we see that as this. All right, so 2'6". That's the pull deck, all right? But this, no. So if that's 2'6", I have to do this. Let's do that. Nah, I'm gonna keep it like that. They don't reveal that to us. Which one, you know, is it like, I think it's like, oh yeah, that's right, I did a video on it. Yeah, we can see the line and the water leakage. It does reveal itself like that. So there is a gap here. It's not like this, because then the water would be out here. It would be no water right there in line. So there is, it's like that. So they build this, and they put reinforcement in it. Let's grab that and change its colors to blue. Okay, now I got blue. So then let me do this. And just trying to give you a rough idea of it. Oh, that didn't work. That reinforcement didn't look like that, but it's giving you an idea how it's tied together. All right, it's they probably did hooks in '90s, and then I don't know, a stirrup system like this, and boxed it up. They won't reveal one of these. Not one is revealed to us yet. This 1'6", I remember it's supposed to be 2'6". They haven't revealed one of these damn cross beams to us yet, and yet they were perfectly revealable over here. Also, this is 4 foot. They changed that to 5 foot bump out. This got changed. They don't talk about that as of yet. Let's go back to this. So the PSI values, I think it's called 10%, and it doesn't matter. It didn't compress, all right? So it worked. There's a stirrup metal system. It's coming there, linking up. And that's the way they do it. But they're just showing it to us. Instead of showing a sample like this, they could show us the real fucking concrete sample. But they don't. They went at it like a bulldozer, right? They went at it like maniacs. And let's refresh the maniac part. I put this now in since this is, the shadow banning, I put this back up. Champlain Towers, and this destroys evidence. I'll put this back in the key as the head video now. And this is the column right here, the one that's in question. It's out of our sight. And they're just going at this like a fucking beast, right? Like a damn caveman. All right, they don't give a shit. So let's fast forward, look at the thumbnail below. They're just destroying this thing. Now, they got hold of the guy that did this video, and the police showed up at his door and told him, stop filming. After I posted my video, and I said, NIST is destroying evidence, they got hold of him. They didn't have a problem with him until I posted NIST is destroying evidence. And they showed up at his door, and I did another video after that saying, look, I don't give a fuck if they show here. They show up with whatever they want. I'm not removing shit. So look at them grabbing this one of the columns. They're just ripping at it, running over it with an excavator. Here's the concrete. Remember, they play jackhammer games up here, like they, trying to do whatever. They're just ripping at it. Right back here is our K, which was so critical, and yet they're so focused over here, thinking this is the one that they missed right here. All of the engineers there, not one said, I think it's this one, and yet I put up a rectangular array video. So it shows you that none of them really are concrete people. In fact, NIST reveals that by saying they had to hire an outside contractor to talk about the slab. So why didn't he just talk about it? Why do you need NIST? All right, they're just grabbing it, just trashing it. Just trashing the shit out of this deck. It's the sample they want. He's right over where we fucking need. This guy just crushing the deck. Mangling the deck with this excavator and this loader and that loader too. Just tearing it up. So, and that's what we needed. They said, oh, we need this. Wrong. And then I'm going to let it play in a minute where we show them destroying it. So they punch holes through here. Punch holes through there for lifting. All right, everybody's standing around. And they're going to lift it up. All right, so they had a saw cut again. Let me fast forward in fact. Let me pause my this is public now, so you guys can come look at this. And he's giving orders. And I fast forward. This is me jumping around. I have the full content, but I just showing you what I made a video of. And this is the guy scraping the top off. You see him? They did that many times. They pried it off. There it goes. Concrete falls down. Rebar falls down. There's some rebar there. This is what they're going to make their evaluation of. Now, it's the guy on the radio telling the guy, boom up. Okay, stop there in a second. And then this guy's going to come over and start ripping the steel out. Let me cough. Okay, let's get back to it. Let me fast forward. I don't know if I point the right one here in this one. I think I might have been off by one. I did it a couple times where I was on the wrong side of the building. All right, let's get rid of the evidence. Boom, 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 boom. They could have put this up, put it in a bucket, in a dumpster, and then put it aside if this is that critical evidence that they did this much work for it. No. And here he's going to toss some steel, move concrete off, all this evidence. Pull that rebar out, toss it. He just tossed it. And I'm going to stop there. This is the point I'm making, is that this is just smoke and mirrors. It's millions of dollars worth of bullshit. She says that she's going to say later in the video how they took calcium samples here or there off the deck. Well, watch how this guy treats the deck. Bullshit. I don't, what deck did they pull them off of? This is the mapping. Right here, I talk about it in this video. That mesh looks pretty damn good. The wire rebar, how they lay it this way and that way. Looks pretty good there. It would have told a lot. This is where the cars were. But he went at it with an excavator. And just wait till you see where he grabbed the slab over here. And this one here, they just go at it. They go at it like they're in a rush, in a hurry. They're not evidence collecting. Look at that claw. Coom. They just said they always were on site. They were always monitoring what the crews were doing. Bullshit. I found the other video, which I now can't find again, where I put a video up saying that they told the contractors what to look for. How the hell do they know what to look for? Obviously, they didn't care. The NIST didn't, because they just look at this. Here's a piece of. This is where the cars were, right? They're just going to grab it and toss it away. All right, these are big excavators. Just tear it apart. But it took some ripping, and I'll tell you something in a second. Hold on. Right there is where it identifies itself as being able to come off in a section. And when you pull one section, look how big of a piece it stayed together. He's really grabbing a nice heavy piece. Look at the rebar holding together. Remember rebar pull-out test? Well, that's a hell of a load on it. And then I jumped to that one. He was able to move that away. There's another piece. So it's holding up pretty damn good. That rebar and the strength of it, holding up pretty good. And then they're gonna mangle at one of these to pull them out. But I'm just showing you that they held up pretty good. But this is what I want to show you too. I just fucking blew it off. Hold on. It was right in front of you. Hold on. I've been waiting to see this. This bullshit they're talking about. Wait a minute. Let me do this. I gotta pause it just for a second, and you guys are gonna be like, "What the fuck?" Yep, it's there. Wait for it. If I catch it, I gotta catch it just in a second. Right there. Over here. You see this comp? Now I'm just bullshitting you. Look over here. It's a drone. They were flying a drone, so they got video evidence, but they're not gonna present that to us. They were flying drones down there. You know, they were flying them. All right, so you know, there's more evidence out there of this construction. All right, but they're fucking around. Let me see out here. Somebody looking at comments. Sorry, looking at comments here. I gotta move this thing up and add it away. Oops. I remember the destroying evidence lesson. Hey, Randy. Yeah, now let's get back to this guy, and let's go.
None of those conditions are met in this instance.
None of those conditions are met in this instance. Well, this is a drawing they have. Show us the real thing, so you can't believe them, right? Don't believe your lying eyes. They're just saying, trust what we just said. Why? Just show it to us. I mean, you know, treat us like, you know, treat engineers and everyone else in the public with respect. Show the real image. Don't show some diagram here that you're claiming this to be true. All right, so there's a 7-inch. This is in front of KLM. It's going in front of there. That's the only place where it steps 7 inches. Right here, 7 inches. KLM. But remember, I did the value over here. That's 1'6". That's a reduction of. It should have been 2'6". Well, did I get that right? Put that like that, right? What did I put it like that? Let's compare it against theirs. All right, so here's 7 inches. This will be 7 right here. That's their 7. And this will be 1'6", although they got it directly in line with this is on a column. But not on a column where the span is between they got it directly over a column here. But between here, it's now this, not 2'6", not even 1'6". Because they pushed this out for the car ramp up here to come through. They pushed the porch out, and they changed the elevations higher so you had more clearance until you got out to here. It's the driveway to come down. The cars didn't come down and turn here, so this one they only had to do 7 foot over here, and then you had this BMA here, which aligns with the column, lines with the garage, with the driveway. See it? It comes down, lines with the driveway. So there's that side there, and this one lines up with that. but they took an additional 11 feet off the building and elevated the porch for car clearance. Not because they were being nice to that family 111 building. It was for headroom clearance for vehicles. And this now is jumped from 2.6 to 1.6. Remember that. So this is only over there, over the column.
We've discovered several places where the construction did not meet.
All right. So this might be our K, because I saw debris on top of K that was kind of bluish. Position. Remember I talked about K. It says yeah, line K. This is where I reveal that K is in the image. I say, look, this is K. Is it over? Is it? Do I have it up again? Where I said this is K right here. That's K. And there's the planter box. It's flat. Again, they're going to show a rotation in their design where, why would it straighten back up? It wouldn't. The tug is somewhere about here, secondary tug, I believe. And then that. We're never going to know what's back here because they don't reveal it to us. Although they knew to hunt down there. I showed you with NIST hunting. Excuse me, with the ball camera. I said the dog ball camera. Where that was Russian news. It was now banned from YouTube that had that video. Okay, go for it.
Not meet the requirements of the drawings, the building code or common practice.
It said did not meet the requirements of the drawings. Let's talk about, every time he says that, I want you guys to know these are the drawings with the BMA. So every time you say didn't meet the requirement of the drawings, tell us why they were able to remove this and this rectangular array. That's as simple as that. K is our problem. It's not, that's it. Now, as far as this goes, this goddamn building switched and mangled this thing and rotated it. It is before the excavators got in there, I think. And this would tell you that it was this direction, twisting, I would say rotating that column. No, because this is still straight up and down. Okay. So it's simple as this. I see it now. And I need a drawing over here. So we're looking at this. That was stupid. I could have just used this. So let's pull it over. So look at the rebar and tell me, how do you get it?
We have previously reported that the upper layer of...
How do you get that rebar to... And keep in mind, this rebar, it looks like it's down here. But this looks more deformed here. How do you get that deformed rebar? Well, it looks like it has a moment here. So if I would have put the column back and I would have pushed it away towards, in line with the building, in line with the structure, it would push this rebar out. So a shift to the right. And this looks like it's bent towards us also. Yeah, shift to the right. So bringing this over, K column, I'm bringing over something to you. So here is K. So a shift this direction. Shift that direction would give us our positioning of the steel like this. A lateral shift. And I would say it's pretty damn low. You know, that it held on pretty good. That sausage, if you will, above this, the next stage above it, was pretty strong to be able to shift this and bend this much steel. 1, 2, 3, and this one, it's interesting. This one is impacted the other direction, but this one looks more, we can see the top of it. So if they had more images, we'd be able to evaluate it even better. And then it broke free. And there's our overlap. Also, that's the top, the end of the rebar. The last bit of it. Now, looking at this fabric, trying to line it up. So this wrapped around. Is this an inverted image? Switched around image? There's a door right here. See the door? Hinge? There's a door hinge right here. There's some peeling paint. Oops, sorry. Right here. Some paint flaked off. This is... There's a door in the background with the hinge. Behind it. I don't see a door behind it back here. Look at the material here. Now there's only two, though, straight up in the air. So I think this is during demo. Since there's only two left at this point, I think they must have been out there doing something. Because I only see two pointing here. Now we clearly see a lot more above this fabric. This one's bent over the other direction. This one. No peeling paint here, so it's not that face. There's a peeling paint. All right, so nevertheless, this got torn off, and during the next part of this collapse, this is cloth, this is material, right? So something went over the face of these heads, knocking at it again, impacting it, and doing so, it also dropped down, and you think it would be more material, whatever this was left behind around it, but we don't observe that. It's like a one-off piece that happened to rip around the steel, which is very interesting on its own. Let's go.
Area of reinforcement in the pool deck slab was placed lower than specified on the structure.
All right, this is where he's going to lie and say that the steel was placed on the face.
Drawings, and that the bars over the tops of the columns were spaced further apart than intended by the structural drawings. We have found that both types of defects also exist in the slabs within the tower. The photo at the upper left shows a specimen of the first floor slab interior to the tower with the same defects. The top bars in the slab over the column are spaced too far apart and are placed too low in the slab.
So this is where they're trying to say that, but we know that the way they remove evidence sucks. The way they inspect it and check it sucks. So, they throw away rebar. If you could actually prove it by zooming in and saying these are the holes where the rebar was, and there's no other holes between it. So, and we know this is the column here. Then you could argue, make that clear to us. We know that they didn't place it over the hedge correctly. But this is it made it for 40 years, and the main building, it was not the precursor of this collapse.
Both issues reduced the strength of the slab over the tops of the columns. We found column.
It says it reduced the strength of the slabs over the columns. So he's clearly the way you think, make a column, put a slab on it, have the rebar stick up through the slab, and then you attach your next column to it. You finish off your column, then your next slab. That's where you work your way up on the floor on this one. You can see that no column is left behind with this. It's just all pad.
Columns recovered from the collapse, in which the cage of reinforcing bars is not properly centered in the column. The photos at the bottom center of this image show that in this particular column, the bars were badly off-center. The left photo is taken from the southeast, and the right photo is taken from the southwest. This column is at good line K on the south edge of the column. The numbers within the inset on the right photo demonstrate the ideal bar locations, and the notations on the photo demonstrate that we can see each bar. Several of the bars in that photo are severely bent, but the superimposed lines on the left photo show that the bars are on the order of 3 or more inches away from the south face of the 16-inch square column. This means that the bars were up against the face of the concrete on the north side of the column.
Now, he's trying to claim that the bars were against the face of it. So when rebar is placed at the face of a column, meaning lacking cover, this has got plenty of cover, you'll see it. It will crack. The concrete cracks. All right. It's no. Now that's the one. It's not when if it'll crack. It's when it will crack. It will crack. If you put rebar close to the surface, you will see it. You'll see the mapping of the concrete. There is no mapping of any cracks, as you just said. So that is a lie. What he's stating there. It is a lie. It's not in any engineer report stating that they saw. They could see the mapping of the rebar below the concrete, indicating that it's lacking cover. That's when they usually do jacketing and things like that to get better cover and protect that rebar below. I've seen it, quadrillion times that rebar placed so close to the face that you could see it map through. And sometimes it maps through because of the lower PSI. And the swelling of the concrete also, rebar. This is where he's talking, here's the K, right there. And he's claiming, per this image, that it lacked cover. Bullshit. And if it did, the stirrups picked it up anyway. Stirrups go around there, go around the steel to hold it all together also from bursting out. So like your belly, your stomach is your stirrup. When you eat all that extra food and your stomach starts stretching out, your skin and your belly becomes your damn stirrup. If you would run a knife on it, you'd probably open up like a pig. Anyway, so the this that has the stirrups wrapped around it like that. And these are the stirrup rebar he's stating, and he's putting the numbers here. And I think he's trying to imply that they're real close to the outside edge without the cover. But don't let your lying eyes tell you the truth. There's fucking plenty of cover there. There's no fractured concrete bouncing off there. In fact, it was so strong that you're able to grab the top of this rebar under that force and bend it away, and you still didn't split this concrete. You see my point I just made there? This was bent away, and you didn't pry away this concrete. So for him to say that that's wrong placement, it was placed against the forms, is bullshit lie. There's the stirrups right there. It held up.
This affects the strength of the column, and as we will.
And it doesn't affect the strength of the column. This did not affect the strength of this column. The column is still there. A building fell around it. You took photographs of it. It's not bent over. It's plumb. It's there. You didn't affect the strength of the column, especially when they beat up on about the bottom of the column. This another column. That's after they imploded it or whatever the hell it was, but or banged at it. But none of them. This did not. This is at the collapse zone, and it stayed strong. So you look somewhere else. If this one stays strong, why would, if that one stayed strong, it's K. Here's L and M. K is tied with this BMA across it, or beam type A, if that makes you happy. It's connected over to here. Here's the crazy part about that, is that it's connected there, and yet, maybe it's in this one. And this is the part I find amazing, is it's connected there. I guess I could have gone, oh, I wanted to come here. This is what they're trying to argue. Was it the building that separated first? Crackpots. All right, let's see. We're getting there to what I want to do. This is K again. See them in the air? That's K. There's the planter box, nice and flat. This is the one that failed. This is that number with the efflorescence and everything on it. This is the one that's still strong. And the deck tugged down and pulled on it. This has a BMA across it. And yet it didn't pull down. That BMA pulling down didn't. This one's still strong, standing proud. So is this one. This one had that BMA connected to K to support that deck. It had beam type A, if you, like I said, I'm not, I guess I'm going to get a little crazy, but not too much about it. Right here. And then it's a cross beam here. And then another cross here. A transfer beam, cross beam, transfer beam. So right here is where K is. And it's not on there anymore. I'm looking at that beam. Remember, it's reduced in size from 1/6. I don't know. I've calculated 1/6 over here. It's 1/6 here, but the total, it's bigger than one. It's a 1/6 step up plus the thickness of the deck, so it's about 2 feet over here that's left behind in the finished deck, and over here underneath of this area, K, L, and M, it's 1'6", considering a 7-inch step up is continuous, and that changes when they put the tile on. But right here, there is no BMA. Now let me just go better than that. There's an image. I talk about that crack, if you remember, that goes across. There is no, the BMAs didn't stay in place. at that location where the one place it could have possibly stayed the strongest, it's gone. So from here, there's K, and there's the next one in line. There's a BMA going here, and then there's a transfer beam going here, and then there's a beam going here and here. Well, if this goes down on its own, just right here, this green end goes down, this breaks this box. And remember I said the box is in pretty good shape. If it went down left first, it would crack the box first, so we would see it like the box here, all cracked up. But this box is in such great shape. It indicates that it's like it fell laterally, just like sheared away from the wall laterally and went down and made itself flat. And remember, I have that one palm tree over here indicating the same thing. It's still standing straight. It's not leaning towards us. It's leaning with the palms, in a natural plumb direction. So it indicates that this part butterfly down, but this part more came down together. Just that the stresses punched around here, including pulling down this BMA from here, connection from here to here, just straight down. Again, look at the box. It's in good shape. And considering it's there underneath the deck, that this is there, considering it's there, I'm believing it's there. They never talk about it yet. That one's there. There's one from here to here. There's another one from here to here, holding that, supporting that elevation change. It's just amazing. Let's see if I can thumbnail it. Here we go. There it is. See, flat. If this side went down first, this would not be level. This part of this concrete would not be level. It would, I already did a video on that box actually. That middle box, this one, but level. Level. There's the brushes. See the bushes? Brush. All level. Not leaning towards us. Not what we can see into the planter box. That it fell forward and it's rolling towards. It's level. It's level from our eyes to away from us. We don't see the grass. We don't see the backside of the box. It's level. I already thought of that it goes down on an angle and then the back of the deck hits it and smashes it down. Then it would still smash it apart, and yet the top views of it even don't indicate that. Oh, this one went through some software. And there's the brush, the shrubbery. She says it's 3 foot deep. That the box is full of 3 foot of earth. Well, that's pretty big shrubbery there. There's the box. There's the steps over here, and that's that return, a little bit of return with the steps. All right, back to the content.
We'll see later today could affect the collapse of the tower.
Could, he said.
The photo on the left shows that the alignment of the
So he's talking about the cover, concrete cover sucks, right? Well, I'm looking at it here. This one might be, I can't tell from here, but there's their stirrup, and there's the cover. Pretty damn thick to me. Now, he's saying alignment. This is after they already drugged us over to a new location, and he's now going to try to tell us, gaslight us to tell us that this alignment's going to give us some information. All it tells us is that when you put it here, this is what it looks like. You got to use forklift, you use excavators, you drove it in a truck, you moved it from an outside yard to an inside yard, and now you're going to try to gaslight me and tell me this is how you found it at the location. So you know what I call bullshit on that? Not once, but twice. This makes me angry. And this thing here too, same thing. Just really, you found this like this? Or did you clean up everything and break it like that after you guys were in there with the demo company? So this is just bullshit lies coming at you right now.
The concrete column story to story was erratic.
They're trying to say that this concrete was erratic. That it was erratic with the build from one floor to the next. Okay. So how would you be able to prove that? Is that you'd have to see this rebar undeflected, and meaning straight lined, and also that the concrete shows no fracture. That's where the floor would be. He's showing it from this angle. Photograph it from the other angle so we can zoom in and see that. Let's see that it didn't bypass each other and that this erraticness wasn't caused by you guys moving it. Part of that, just measure the fucking thing. You know, you measure this, it's perfect. You measure that, it's perfect. I don't think it was erratic. I do not think it was erratic. No engineer came out there and said that it was erratic. You know, when they had a couple of inspections over the years, nobody said, oh, as I look up your wall, it doesn't look plumb. But he's now claiming it's erratic, it's out of plumb. I'm calling bullshit on that.
The superimposed yellow lines and red arrows highlight the issue at one joint, and it is at least as bad as the joint further away in that same photo. The worst misalignment measured in recovered specimens is on the order of 3 times the tolerance allowed in ordinary construction. The photos at the bottom of this slide show a basement column from the tower while still left at the site. The lower bars are dowels extending upward from the foundation. The upper bars are the main reinforcement in the column. By design, those upper bars were to extend down to the basement floor slab.
Yeah, I looked at the design. I didn't see where they demanded that this go down, all the way down. Nevertheless, this didn't fail. This was from, you know, the other part of the building, the pool deck failing. So what you're picking over here? There's nothing to pick on over here. Stop picking over here.
The photo shows clearly they did not. Several column specimens recovered from the collapse show a similar arrangement. The image on the right shows the result of measurements on one specimen in the warehouse taken with ground-penetrating radar.
They used ground-penetrating radar to try to show you, tell you that this is the depth of this. So they would have to use you got to be shitting me. You had full access to it. Why did they use ground-penetrating radar? I'm confused. So this is here's the column. I'm leaving that alone. I don't get their ground-penetrating radar. Maybe going from this direction and surface checking it for it's a damn metal detector is all it is. Let me just go move on. It tells you the depth of rebar under 6, 12, even 12 inches. It can tell you the depth of it. You can map
The important defect is that the length of the overlap of the upper and lower sets of bars is far less than specified on the drawings, and what was specified is the minimum allowed by the building code. This short overlap of the reinforcing bars led us to conclude that we needed to construct a few replicas and test them in a laboratory, which will be described later today by Jack. Mr. Segura will now describe some of the field testing.
All right,
All right,
221.
thank you, Jim. Good morning again for those of you who might not have heard.
All right, so I'm going to go to 218 now. 217. This testing is just of rebar. They grab the rebar and they pull it apart. It's stupid. It serves no purpose. Rebar pull-out tests work better. You just grab that concrete there, you cut away you grab hold of a piece of rebar and you start pulling on it till it fails. This is just stupidity in itself. I don't even know if this is a true sample there. That might be a mock, a fake.
One number 5 slab bar and one number 10 column bar. For each test, we capture the full stress strain response up to 3% strain, at which time the extensometer.
I'm waiting for 217, guys. They moved this out because they don't want to damage it.
Is removed to protect it from damage from bar fractures. We also measure the uniform elongation and the strain at time of fracture, both of which are illustrated on the figure for the number 5 slab bar.
So they got it. It's a 60,000 psi bar. It went above 60,000, and they're going to rate it at 60. He said, but it's way up here at 65, and they use 60,000. Is what they're going to do.
The stress strain response that we observe for these bars is consistent with grade 60 reinforcement.
Yeah, 60,000, and it doesn't fail. Well, it doesn't fail. This is when they remove this tester here, this elongation thing. But it doesn't fail to over 100,000. All right, then it pops off. So the rebar was so good that they ordered it 40 years later. It's 60,000 psi rebar. All right, if you will, kips, whatever you like, 60,000 rated rebar. And 40 years later, with elongation, rust, all this effervescence they talk about, that it's jacking off the metal, it's doing this, and everybody's saying it's getting down to the metal, and it's doing all this to the metal and ruining the metal, and it's ruining the bond. Well, with their tests, their 60K didn't start moving until 65. And then there's your scale here. And then this is a weird break here from here to here. This is actually some elongation and rehardening that goes on. So somewhere about 90,000, 85,000. But you're definitely, if you're out here, that rebar is really deforming, but it's holding on. It's got this weird ability when I do my rebar pull-out test to stretch and give you a higher value. But that stretching is not for free in a concrete environment. Your concrete will be moving and the failure would have happened way before this. But it's just showing you that this rebar is supposed to be so shitty, made it up to 105,000. Here's 105,000. I like the number down here, about 90,000, 85,000, 87,000. Somewhere about there. And maybe if you want to be lucky, come here. Nevertheless, it outperformed its requirements, considering that's the 60K bar, like he just said.
This slide shows the compressor.
Now, this is what I wanted to get to. This is the charm. This is all I want to do the video on. This one here, and yet I've ran rambling on this far. So hopefully you'll get this part real good. So stay with me here. This is the cool part. He doesn't even know what he's about to give up. It's so beautiful information that why I'm always a little bitch about something. Here we go.
The compressive strength measured for cores extracted from a single evidence specimen that contains column concrete from the basement as well as concrete.
So he's pulling samples from this column here. All right, take note of this column. Right here is wire. This is the back wall, and this is the last one. There's no column beyond it. Let me see if I can pull up the image for you real quickly. And where are you, sweetheart? Not that bright now to pull it up. Oh, I can pull this one up. So let me make sure you can see it. Good. Here's that slab. Remember he's talked about the slab? It's too thin. The cover's only 3/4 of an inch. I don't know if I can enlarge this. 3/4 of an inch. That's too close to the surface. Well, there's where the tile were on there. And as the tile is removed, as we observed, and this is down, there's samples they just toss over here in the fucking dirt with some parts high, one low, whatever. But the, let me see if I can pull this up. Oh yeah, I'm going to be able to save this one real good. Hold on, trying to pull it up for you. Okay. Balcony. Ah, shit. I don't care. Balcony, what I care about is 3/4. I gotta be careful. It won't do some things it won't let you do when you name something. 3/4 lie cover. NIST. I'll do that. And let me pull it up over here when it pops up. Okay, good. So this is going to be good. So this is the 3/4 inch they said is the cover, and that was a problem on the balconies. This is round shape. That's one of those balconies. Let's see if we can do a zoom. Shit, sorry. Oh, shit. Hold on. I have to do this. Not again. There's where they punch through the deck. There's the rebar. There's the top of the concrete. As you look around here, this is, maybe that is tile. But as we look to the rebar over here, remember you said 3/4? And now we're going to look for that cracking, that mirroring through. There's something pulled off there. There's a pun bar there. I think this is the doorway when you step into the building from the deck, from the balcony. So I would like to see some stirrups out here, but some 180 some hooks, but it didn't go that far out. Like right here, I'd like to see some hooks. If anything, it looks like it's missing the hooks. I think a hook should have been there, coming out from that direction. Considering that's the doorway, this steel has been bent. So there's a pull-out test by accident. It's been pushed on to be able to get in there with an excavator, let's say, and it just deformed, but it didn't look like it didn't do anything else besides deform, stretch, if you will. Okay, so from here, this is concrete, to here on the deck. There's that approximately 3/4 what the engineer called for. But they said it should have been 1.5 inches, and then this is the extra cover of the tile. There's the tile. So it appeared that worked, because even with this little bit of rebar, this is the weakest part, we would see it flake off. So I'd be able to come over here with a hammer and tap this to break this off. So even with them jumping around, throwing it around, etc., this piece of concrete stayed bonded to this steel right here. This is a great indicator of its performance, the concrete performance. I lost your comments if you're commenting. Sorry, let me see if I can find it. Yeah, I lost it. Give me a second. Where are the? I think I just lost them. Don't know where I put them. All right, so let's look at that again. See a rebar. This has been out. This is overlapped there. It's good. You can see the deformations in it. See the shape? So it didn't rust. You can see the rib down there still in great shape. Great shape. And yet this is exposed to the elements. You know, the deck, per their thinking.
concrete from the first floor slab. I'll refer to this specimen as column A. The image on the left shows a photo of column A in early July 2021 before this portion of the building was demolished. The table shows the individual compressive strengths measured for cores from the column and the slab. For the slab concrete, the average strength from 2 tests is 4,450 psi, and for the column concrete, the average strength from 2 tests is 8,520 psi, showing clearly that the concrete mixes for the slab and column are different.
Ah, shit. Sorry, guys. I had it, I got the audio back now. I'll start over. Audio back. Audio, sorry. Sorry, guys. You can hear me now? Wait a minute. Audio back. Check again. You might be on a delay. Audio delay, maybe. Yeah? Yes? Okay, it's hard. Okay, audio back. Tell me where I left off. I'm going to go... so, did you hear me talk about Randy's comment where Randy said 3/4 inch? Did you hear that? I'll back it up. Let me back it up. I'll back it up and go again. So, it's hard to find the images on the internet is what I was doing, what I stated. I had a cough, and when I coughed, I put the mic on mute, and I thought I took it off. Sorry, or sneeze. So, thank you, Randy. So, what I'm showing is that he's calling this specimen A, and this one's specimen B. All right. If you see behind the car, there's the white car here. This is a column. Hey, thanks, Geraldo. So, Geraldo. So there's the white car, and that's that one. So he's calling this A, and all of a sudden this one B. How come it's not like A, B, C is what I'm saying. It's kind of deceptively. Also said if you waited this long, you're going to get you're going to love what I'm going to run to you. Let me back it up so he can start talk about this column. I think you heard me when I talked about the steel, right? When I talked about the steel stretching.
Concrete slab
Let me let him catch up to us. He catches up in 2 seconds.
Concrete or column and wall elements.
I'm going to mute him.
For each figure, the bar on the left represents...
I'm going to mute him until he gets to 217, and I'll just go back to what I was stating. That I'll jump back over. Is that... Let me pull this back over, because I showed you this when I was muted, I think. So this is the column. This is outside. This is the BMA, right? And there's right here, over to that column. So this will be specimen A. Then he calls this B. But for our purposes, say A, B, C. All right, 1, 2, 3. There's a BMA that's supposed to go through here, and then this comes across, and there's a 1 foot step down. This column is what he took that first PSI on that he's going to say in a minute. It's outside the elevated deck. It's elevated deck that was for parking garage at 1 foot. It's outside of there, outside of that elevated parking area. This would have been that 1 foot elevated. Let's see if we're back in now. Almost, he's got another minute of yakking. If I try to find in 1 minute, it doesn't work that way. Tiffany, 10 minutes ago. Tiffany, I gave you the short version to catch you up, and I'll hopefully I'll find it in the video and clip this out on YouTube. I can go back later in a few hours and edit out the 10 minutes of dead time. But I have to first find it. So it doesn't correlate to, well, maybe it does. Let me see. I'm talking to you now for 2 hours. Let me write this down. 2 hours and 42 minutes. I have to fix video. 2 hours and 42 minutes. Tiffany says 10 minutes. Tiffany says 10 minutes of quiet. Okay. But I caught you up to what I was, the short version. If you waited this long, hopefully, did you get this part right here? This was the elongation part. Let me wait, because I wanted to go back over this one then. Did you catch on to this about his steel testing? I'm waiting for a reply down here in the comments, guys. Did you catch on to that when I talked about that rebar and the graph? The graph to the left? I'm looking for a reply. I know there's a deep... let me just write it in the comments. Hopefully someone will say it, but... Wait a minute. Did I go over the graph with you? Over the graph? Waiting for an answer. Was that audible? Okay, yeah. So it shows you audible, right? Audible. O-A-B-L-E. Whatever. Audible. I like that. Did you hear about the graph? And yeah. Okay, good. So let's jump back into it then. Let's let him come up to the column. And he has no idea what he's about to give up because he doesn't do a conclusion. He just gives the PSIs. And wait till you get the beautiful PSIs of it. While he's there, I'll drag this over to here because you're not missing anything till it comes up to, well, we should be approaching right about now. Let me get the audio back going. Excuse me, it's 2:18, I think. Let me audio it.
This slide shows the compressive strength measured for cores extracted from a single evidence specimen that contains column concrete from the basement as well as concrete from the first floor slab. I'll refer to this specimen.
Christine Collins fell asleep on me. I hope you saw your Christine. I hope you saw your. I did a video for you. Thank you for your support. It was a deep meditation trance. Yes. Yeah, we saw the graph. All right, awesome. Thanks, Randy. All right, so now we're back to the column here. So they're testing that one that's furthest away. There's the electrical conduit, and I showed you that with this saying that. Let me move this over. That the right here, there's the electrical conduit running down there. All right, I think it's the security system, the alarm system. Boom, boom, the lights. So there it's there. So he calls this one column A, and then the one closest farther away he calls column B.
Column A.
So why didn't he call it column C? It's kind of deceptive.
The image on the left shows a photo of column A in early July 2021 before this portion of the building was demolished. The table shows the individual compressive strengths measured for
Yes. Okay, how's the audio? Is audio good?
cores from the column and the slab. For the slab concrete, the average strength from two tests is 4,450 psi. And for the column concrete, the average strength from two tests is 8,520 psi, showing clearly that the concrete mixes for the slab and column are different.
Okay, so now he calls this column B. Column B, but remember there's another column midway between there. So now he's going to go over the PSI, and he's going to state something that he has no fucking clue how important it is for us. Watch this, guys. For me.
Now let's compare the results for column A to another column that was constructed very close to column A in the CTS building, and that I'll refer to as column B. I'd like to draw your attention to the variability in concrete strengths while keeping in mind that columns A and B were constructed very close to one another.
Bullshit. They were not constructed very close. They were fucking a million miles apart. This is A. There's that carbon background next to this one. And there's his B. So they were the opposite ends of the fucking building. So this cox nibbler is saying that they were, keep in mind, he's going to tell us the narrative. Keep in mind they were constructed very close to one another. Bullshit. This, it's the supporting the structure, and there is the one between it, and this is the end one. That's this little lady right here. All right. He could just say where the fuck they are, but he's going to play. They playing fucking games here. All right, let's get on with the game, and then I'll reveal it.
Within each sampling space, the highest measured value for these two columns is indicated in green text, and the lowest measured value is indicated in blue text.
So the pad over here is at 5,300. The pad over here is at 4,400. You're doing a concrete floor, right? And you're doing it. Remember I said I want to know where, this is one of the things, want to know where they made their joints. They're stopping and starting. Well, obviously that day when they were pouring concrete, somewhere it stopped between from here and before they got to this one. A different pour, you then got the higher PSI. Just so you know, you won't start off with a stronger pour and then make it stronger as you go for the day. So you don't start off with 4,000 PSI concrete and then by the end of the day, your concrete increased in PSI. No, you might have started off with a value. In this case, if I look at this, they might have ordered concrete at 5,000 PSI. The manufacturer, the supplier, sent them concrete that made it to cured 5310 after they placed it and all. So they might even order 6,000 PSI concrete, and they only need to get to 4,500, and he wet it down. He just used a lot of water, losing PSI value doing so, taking longer set times, but your loss of PSI gives you, your loss of PSI because you use higher water content gave you better workability, and you still wind up with a range above what you need, say 44,000 PSI, 45. This day, when they did this one, it bit them in the ass. Maybe they used too much water, maybe it dried out maybe they used too much water, or they cut it close, that day give me 4,500 PSI, and they wound up with this. All right, so there's his test. But it shows that these were two different pours. Or that day they ordered 5,500 PSI. They started pouring it, and right about here they started watering it down because it was getting too stuck. It's too stiff. Now here's the problem with that. This is not one truck. This is multiple trucks. All right. So it could be as simple as one truck had a load that was this much. The next truck had a load is that much. But that's not what I'm explaining how you can get to multiple PSIs. Different trucks, different PSIs, different pours, but the manufacturer's not giving away free cement. All right, they're not giving you they are giving you a PSI that's going to be greater than. So if you order 5,000 PSI, they got a state mix, for example, they have to pass it every time, at least 5,000. So they will give you extra concrete in state mixes. And when I say concrete, I mean a stronger mix, so they'll always pass because they can't have the mixes coming back as a fail. And they get tested at the plant. All right, so this shows you multiple trucks or different pour days, but it gets better than that. Wait for his next information that he doesn't even know what he's going to say. That's so critical.
For the first floor slab concrete, excuse me, the low value 4,420 PSI for a core from column A, and the high value is 5,310 PSI for a core from column B, for a difference of 8.
I don't care about the difference. That's the floor, all right? And I just told you how you got to the difference. All right, that's the floor. Just keep that in mind. Watch, here we go.
890 PSI between high and low values. The data for the basement column concrete is particularly interesting because
Now he says it's particularly interesting because he's going to get these much higher values, different values. But there's one more thing that's going to be so critical that he's going to blow right over and not know it. And I'm going to let you catch it. But this basement, meaning when you're in the parking garage area, this is below the pad. When you look up, this is the column area. So let me do something for fun for you. Let me pull it open here. Hold on, let me move something aside for fun. Oh shit, I'm gonna ruin my fun. I'm gonna step on my own toes. I'm gonna wait because I might lose the image I want to show you.
As we see that the measured strengths for the cores from column A are considerably higher than those measured for column B. with a difference of 3,390 psi between the high value of 8,680 psi for a core from column A and the low value of 5,290 psi for a core extracted from column B.
Okay, so he did multiple cores on each one of these. This drawing here, let me make sure you can see it, yeah. So right here is this column here, this is column A. He got from the basement, he was able to get, this is where the deck goes on top of. So this part right here, he got multiple samples, high and low. And then from that other column that's way over here, let's move this out of the way. I keep messing, it's back here, this one. I believe it's this one right here. All right. He had $69 is the high, and then $52.90 as the low, or multiple core samples out of this column. But let's keep in mind this number one thing. I don't give a shit what he had. Does it look like it buckled to you? Did it collapse? Did it fail? All this tells me is that, all right, this concrete was overrated. This concrete was working also, so they could have saved money in hindsight. So this helps you in future, telling you can get 40 years out of 7,000 PSI concrete on a 12-story building. You get 40 years out of it. Look at it. I mean, it didn't even, when the deck was collapsing around it, tugging on it, pulling on it, that rebar stayed in line. Remember that the engineer said this stuff was all out of line and all that. All this stayed in line. It had a significant height difference from here to up to the first level, to this level, all the way down to the floor. And only thing that kept it bridged, if you will, that from buckling in this height was the floor. Now the floor is gone. We observe a column that's significantly tall. I don't know if that's 11 feet now. That's 11 plus the 6 inches plus maybe another 11 feet. It's just like a 22-foot column we're looking at now. And it didn't buckle. Neither is this one, neither did this one, and neither did this one, even with all that rattling and shaking. And it's of this dimension. It's huge. Here it is here. So that just tells you about his overlap that the other engineer was bitching about, that they don't do proper overlap, that causes problems. Well, they fucking did a great job here, didn't they? All right, so let's go back to this, and it's coming up, the part that I'm going to excited about.
When we only look at the test data for the column concrete from column B, in the bottom right quadrant of this table, we see quite a bit of variability in measured strengths between.
Okay, there's the variability in strength. All right, so that tells me to do as low as 5580. All right, it's like 1,000 psi difference. 1,000 psi difference. Now, he can't figure it out, but watch. Listen to what he says, dumbass. Listen.
Between 5,290 psi and 6,900 psi. And these cores were extracted within inches of one another.
Within inches of one another. Here it comes.
When looking at the four test values, the higher value, 6,900 psi, would appear to be an outlier.
It would appear to be an outlier, and he just points it over here, the arrow. Hold on. It's an outlier. Hold on.
Or in this case, because we were able to collect enough samples from column B, we were able to confirm the presence of a construction joint approximately 12 inches below the slab.
That's it, guys. I just came in my pants. Did you hear what he just said? I'm going to wait for you guys to put it together. I'll move this mouse over. What did he just say? Or do you want me to rewind it? He said approximately 12 inches below the slab. Randy, don't you get it? Remember, the original design intent was a 1-foot elevation change. He found a cold joint. A cold joint, meaning that they added a 1-foot square on top of the existing column. 12 inches they added. This shows you in time when they fucking decided to delete the BMA. That they had, this is when they decided to nix-nay it. This is when they decided it had to go. There was an elevation problem, and they resolved that 12 inches with 12 inches. That it was going to be a BMA. Remember the BMA deal going here and all that? That there was some fuckery going on. And they said, let's do this. And they resolved it with a 12-inch block on top of it.
Below the bottom of the slab. The three cores was measured strengths below 6,000.
Let me do it again. Let me back that up. I'm going to mess it up. 29. Remember I said this thing only lets me go so far. And then it messes up. Let's see if we get lucky.
And the low value of 5,290 psi for a core extracted from column B. When we only look at the test data for the column concrete from column B, in the bottom right quadrant of this table, we see quite a bit of variability in measured strengths between 5.
Remember, he's going to say a cold joint of 1 foot. That's exactly what we need. The 1 foot that I keep talking about. It shows they had intent up to that point to deal with this 1 foot, and then they said, nix that 1 foot, let's do this and that. It's interesting, though, where the 1 foot is. The 1 foot that they added is over here and here. Well, I'm sorry, here that they find it. He doesn't talk about it on this one. It's very interesting. Like they had some other alternate design that they were working with, because he doesn't talk about it over here. And then they said, yeah, you know what? Bring it up a foot, and let's get rid of this. It was some real fuckery going on around here where that cold joint was created. And maybe he did this arrow. I can't be sure if it's 6,900 right here is what he's saying, or is that 1 foot cube that they added? Is it there? And what did the rebar look like? They should have taken this apart, and then they could investigate it that 1 foot intent, because they would say, oh no, the rebar was much further up, and this is where the cold joint was around the rebar, and looks like they jammed rebar down. You could learn so much by taking this one apart. This one too, to see if the rebar configuration around this joint is the same as this one and the one in the back. Interesting, they still have these samples. They could still investigate that, taking it apart and look at the rebar placement, and then use a real engineer or contractor to tell you what went on, to reverse engineer what went on, to say, oh, I know what they did here, because remember, this comes second. So basically, you can separate this and then look at the lower part and see if there's any segments of rebar added, middle segments to make up this 1 foot height. Because this being the finished height is 1 foot cold joint. Let's hear
5,290 psi and 6,900 psi, 6,900 psi. And these cores were extracted within inches of one another. When looking at the 4 test values, the higher value, 6,900 psi, would appear to be an outlier. However, in this case...
So how can 6,900 be an outlier? It's not. It would probably be, since they did all these samples, it wouldn't be 6,900 in the middle and then all this here. It would probably be the cap, the one foot cap that he's mentioning. So the arrows are probably deceptive, that these arrows should be pointing down here. And the 6,900 probably more was the cap, the cap that they put on it, the 1 foot. He called it an outlier.
Because we were able to collect enough samples from column B, we were able to confirm the presence of a construction joint approximately 12 inches below the slab.
I'll stop it there. That's all I wanted to get to you guys today. All of that to get to this. To talk about that 12 inches. Keep in mind that they got to take apart all 3 of these to see what was going on with this intent. But the 12 inches exactly corresponds with the 12-inch elevation change that took place by elevating the deck. I'm sorry. So this is 1010. They brought the deck to 1110 was the final. Now I'm starting to doubt myself. They brought it up. Yeah, they brought it up, because then you lose a foot over here. So they brought it up a foot here. My guess is that when they were doing these, so I'm trying to reverse engineer the thinking, is that we need to see. So what we need to see is the height, the cold joint over here. We need to see the cold joint of all of these, know the cold joint heights, and somewhere somebody was working with two plans, and they grabbed the wrong one, and they made this column this height, revealing that this was the intent, and then they had to change it. They had to go up a foot, the 1 foot code joint, which would put it back right. Somebody did something inverted in their brain. Yep, Randy, the big problem is they don't care. Yeah.
Below the bottom of the slab. The three cores with measured strengths below 6,000 psi are from above this construction joint, and we.
Now, so he says the 3 cores are above the construction joint, so which is weird, because that means it's up here, right? The 3 cores we took, this arrow would put it up here then, because you said this is below there, and if you take it above the construction joint, you're in the floor. So you see where his whole wording is deceptive. Let me go to 9. Let me go back it up so you can hear it again. Where he states, let's start over. Where he states this is the floor. All right. There's a 1 foot cold joint. He doesn't talk about going here. He talks about getting all the sample below. But then he says these samples are above the cold joint. The 3 samples they shot in the cold, but that he calls this an outlier. The outlier, so he's saying this can't be all 6,900. It's an outlier, which is just bullshit. And then the column, look at the PSI difference. They're huge. The 86 to 69. This is telling such a story.
It's column B. I'd like to draw your attention to the variability in concrete strengths while keeping in mind that columns A and B were constructed very close to one another. Within each sampling space, the highest measured value for these 2 columns is indicated in green text, and the lowest measured value is indicated in blue
All right, so that's the floor. All right, 5310.
text. For the first floor slab concrete, excuse me, the low value of 4,420 psi for a core from column A, and the high value is 5,310 psi for a core from column B, for a difference of 890 psi between high and low values. The data for the basement column concrete is particularly interesting because we see that the measured strength.
So look at his arrow. He's pointing down here low with the arrow. 5580, 5600. He's pointing down here. So let's do this. In this slide, he points. Let me do the slide. I'll put it over here. In this slide, he points there, talking about the PSI.
Strengths for the cores from column A are considerably higher than those measured for column B, with a difference of 3,390 psi between the high value of 8,680 psi for a core from column A and the low value of 5,290 psi for a core extracted from column B.
Now look what he did. You see where the arrow went? Look at the left to right. Randy, are they jacking me off or what? They point below. His arrow points below, and now he does this with the arrow up. They just, you can't trust NIST. They can't, when you make up a lie, you make mistakes like this. But if you just tell the truth, you won't make mistakes like this. Look at the arrow to the left. That's where his samples are. Now the next image, he changes it to, oh, here's the PSI up here. How the fuck can I trust anything he says besides maybe the 12 inches? Look at the arrow. Look at it. This is now, this is just insult to intelligence. All right, this is just insult to intelligence. So now he does this arrow, he switches it up.
When we only look at the test data for the column concrete from column B, in the bottom right quadrant of this table, we see quite a bit of variability in measured strengths between 5,290 psi and 6,900 psi. And these cores were extracted within inches of one another.
So the image you just showed to the left shows the samples came down below this detail. And then seconds later, he says, oh, the samples are up here below the deck. This one shows it at the column. This one shows it right below there. Yeah, chick, it drives me crazy too. Here we go.
When looking at the four test values, the higher value, 6900 psi, would appear to be an outlier. However, in this case, because we were able to collect enough samples from column B, we were able to confirm the presence of a construction joint approximately 12 inches below the slab.
So here's the slab right here. This is the slab, right? And 12 inches below, that's immediate below. 12 inches. That's now this. But a second ago, it wasn't. It was down here. And now he points to outlier here. So if I'm to, I don't trust him at all. But if you look at it, the columns down here is a higher PSI. You would think this one would be more true. But why did he, then that means he took 3 samples inside the 1 foot, 1 foot added section. He didn't take 1, he took 3 samples in that 1 foot section. Why would you do that? Why wouldn't you just take the 1 foot section off and go just test it? So let's listen to the rest of it and then wrap it up.
Below the bottom of the slab. The three cores with measured strengths below 6,000 psi are from above this construction joint.
All right. So he says the 3 floors, the 3 cores are above the construction joint, but yet over here to your left, it's down here, and then he pops it up here. So if it's above the construction joint, that's that 12-inch block that he took 3 cores from, and only a single one from below. But he calls that one the outlier. How is that an outlier? He just said it's a cold joint. So a cold joint means it's added the concrete set up and it came and added more concrete later. So this would be what he took 3 samples of the cold jointed area of 1 foot square, and the outlier, as he calls it, is the real column. That's not an outlier. That's the column strength presently, if you compare it left to right, of this being this column being 8,600 is 69. This is it's a hell of a cost on concrete. The difference, I mean. This is some high-rise apartment stuff here.
And we find that the column concrete in this area is the same mix as the slab concrete. The higher strength value of...
Wait. So he's saying the slab, this is the same as the slab in this 1 foot box here. But yet he called it a cold joint. So now I wonder if it was poured together, this and the slab. Yep. Hey, Randy, I just saw you pop up. Thanks, Randy. You see a comment, Randy? Member for 23 months. Wow, 2 years.
Of 6,900 psi is from concrete from below the construction joint, and this appears to be a different mix. A different mix. The results shown here for columns A and B demonstrate our need to extract and test enough samples to draw statistically significant conclusions about the concrete and reinforcing steel and their properties, and to be able to quantify their spatial variability, especially for areas of the structure related to our leading failures.
All right, well, let me tell you guys, he could not have taken a core sample out of these. There's too much steel in this column. He did not take a core sample. He could have taken a cube. Hey, thanks, Randy. Thanks for the $20. Appreciate that, man. That's all right. That's great. So look, let's go back to this one more little thing about it. Is that so he couldn't have taken core samples from there. He takes some cubes, like 1 foot, 2 foot squares, 2-inch square boxes. You can cut them up. So they're core samples. He shows it as maybe 6-inch round, but there's rebar in there. You just don't test it with rebar in it. It just will fracture differently. So you don't do that. So how the hell did they get their testing on either one of these, on this one or that one, with rebar in it? How did he determine that? Maybe some cubes. I don't know his method. He didn't reveal that. I looked up his background. He's just a PhD, no field experience, as far as I know.
When looking at the four test values, the higher value, 6,900 psi, would appear to be an outlier. However, in this case, because we were able to collect enough samples from column B, we were able
All
to...
right, so again, it's an outlier, but as we see, he identifies it two different ways. But then he states that the floor and this appear be the same mix, which what he called this the cold joint of 1 foot. So it's like they poured 1 foot cube, and then they came back with the same mix, and then they did the floor. That's what I wanted to get to you again. Again, this doesn't work that easy with, so that's his core sampler. And I don't see any steel in there. I don't think so.
Strengths measured for cores from the column and the slab. For the slab concrete, the average strength from two tests is 4,450 psi. For the column,
I'm just going to go like that for a second while he walks it up. I want to hear him talk about B again. And we hear him, see, it doesn't really nail. Here we go. Where I put it.
Column A to another column that was constructed very close to column A in the CTS building, and that I'll refer to as column B. I'd like to draw your attention to the variability in concrete strengths, while keeping in mind that columns A and B were constructed.
So what I want you to pay attention for this round is how he talks about the cold joint is the 1 foot. But then he also at the end says that this mix of the floor, and I believe he says the cold joint, are the same. Let's see.
Very close to one another. Within each sampling space, the highest measured value for these two columns is indicated in green text, and the lowest measured value is indicated in blue.
Which he says is the same, but our PSIs are different. Because remember, the floor is 5310, but the cold joint has to be, which, take your choice. It's got to be 5580, 5600, 5290, is the low. And this one he just says is 5310. So is this and the floor the same? They're pretty much in range with tolerances of testing.
In blue text. For the first floor slab concrete, excuse me, the low value of 4,420 psi for a core from column A, and the high value is 5,310 psi for a core from column B, for a difference of 890 psi between.
Now I'll give you this part. So he's saying column B over here is 5,300. Remember, different trucks. And as you go to the other end of the building, the other column, you're down, significantly down. When you put the floor down, you're way down in your PSI at 4,420. So this floor had some huge variances of strength, grip force in the rebar, 1,000 PSI difference. So, or the B side over there had a lot more grip strength than over this side. If you think of rebar pullout test that I do, the higher the PSI with the rebar, the stronger it's going to be at resisting bending, the concrete bending, so loading on it. And in this case, this column being closer to the wall at a higher PSI floor slab with the same rebar reinforcement placed is much stronger than the 4,420 PSI concrete. It's way over there. So this tells you got a weaker floor over there. So don't forget that. That's a weaker floor. That number there tells you got a weaker floor over there. With that said, the floors are the same all the way across. They're the same elevation. All the way across here is the same elevation all the way over to there. But this zone is weaker, 4,300 PSI, 5,300 PSI over here on the floor. So you can see the gradation. Since he didn't take this one, we're kind of assuming that the gradation takes places. And maybe it's from here over to here, it's the same as the 4,420. It's like they suck with mapping this properly. So now you see the strength difference on that. Now let's go again. And I think this will be the last bit of data I'll give you on this one.
Between the high and low values. The data for the basement column concrete is particularly interesting because we see that the measured strengths for the cores from column A are considerably higher than those.
Okay. So he's saying that the column strength now. Columns don't matter for me because they didn't compress. They didn't shear, buckle. They didn't fracture. The columns, I don't care about the extra strength of the column. The floor is where I care about now. And of course the 1 foot indicator of some chicanery going on.
So then those measured for column B with a difference of 3,390 psi between the high value of 8,680 psi for a core from column A and the low value of 5,290 psi for a core extracted from column B.
Okay, so he's stating, remember the arrow, he points down here and then he flips the arrow. So right now we're at that stage with this, my screenshot looks like that. That he's stating that that's the value down there. And then he's going to switch it around to the outlier, which drives me fucking crazy because he just said that the floor, remember he's going to say the floor and this are the same mix. And if that's so, the floor and the 1 foot is the same mix, that's 5310. And then he's going to call the 6900 an outlier, where in reality it should be, you know, that's the base, that's the column. That's the base column, the lower part, below the 1 foot sample. 1 foot cube on top of the column before they get to the floor.
When we only look at the test data for the column concrete.
Okay, so once again, you see now he switched it. This was down below, this arrow, and now it's up here. And this is where the 1 foot square is. Now this is where it gets, you know, funky.
From column B, in the bottom right quadrant of this table, we see quite a bit of variability in measured strengths between 5,290 psi and 6,900 psi. And these cores were extracted within inches of one another. When looking at the four test values, the higher value, 6,900 psi, would appear to be an outlier. However, in this case, because we were able to collect enough samples from column B, we were able to confirm the presence of a construction joint approximately 12 inches below the slab.
Okay, so what this tells me is that they ran circles like this. 1, 2, oh shit. And then this one came out and they saw a cold joint. When they drilled it, it split in half. And they said, a cold joint right here. So they moved down. Maybe they moved down and went 1 and 1 again. I don't know how they missed the rebar, but they missed the rebar. I mean, of course I know how they missed the rebar. They used you roll it on the face of it, it tells you the depth of the rebar and where it is. And I don't know what size core he took though, but it's amazing that he missed the rebar in that column because the placing is so damn close. Placement.
Below the bottom of the slab. The three cores with measured strengths below 6,000 psi are from above this construction joint, and we find that the...
See, now he says it's above the construction joint. Now I'm pointing down here. So in that one construction joint, which we know to be 1 foot, he took 3 cores out of it. 3 cores. Those 3 cores match the floor deck. If you look at it, this is within range. All right, this is the tolerance of his testing. Is samples, so that's the pool deck. This strong 6,900 is not an outlier, but 6,900 would be the column below. Now let's wrap it up with what he says about the same aggregate to help support that.
And that the column concrete in this area is the same mix as the slab concrete. The higher strength.
The column concrete is the same as the slab concrete.
Value of 6,900 psi is from concrete from below the construction joint, and this appears to be a different mix. A different mix.
Right, and it's not an outlier; it's a different mix.
The results shown here for columns A and B demonstrate our need to extract and test enough samples to draw statistically significant conclusions about the concrete and reinforcing steel. And their properties, and to be able to quantify their spatial variability, especially for areas of the structure related to our leading failure scenarios. In the coming weeks, our team will conduct a final deployment to extract samples to help us with our analysis of uncertainty in the material properties and to provide more clarity on...
All right, I'm stopping, but I want you to realize that this is all I came to, is that 1 foot little square was added. The variations in the slab deck is huge as far as strength goes. So if you were to map this, if I would get rid of this crap, if they had using that deck sample, the column sample, so there's that there. So we don't have other samples. So I'm just going to be biased and put that there. This should be one at 5300, and then down on this side we get a gradation back to there. I'm going to change the color to this color. Somewhere we get a transition, a gradation from that column here. I get rid of that. Delete that, do that again. And this column here. We have on this side a PSI strength. On this side, indicated by his measurements, 5300 PSI, 5310 as he averages it out to. Over here, and on the opposite side, way over here, we have down to 4420, which means, again, a weaker deck. Stronger over here, weaker over here. And this is where the cars are parking. This is where we have that deflection over here. Remember that deflection? I got the arrows here. They go this way too. That deflection is not on just that direction. The loading is over here. You have the removal of the BMAs by the engineer and contractor and architect, all of them in compliance to that, agreement to that. There's the other one there. You have NIST not recognizing that this had a 2'6", I'm gonna pull that out. 2'6". Whoops. You got that. You have the offset problem, which is that's a waste of energy. Hold on. I should have that drawing up. And I don't have it up. I'm looking for it. Give me a second. Under the screen might be blank on you. Let me get it. Where'd you go, baby? Yep. I'm going to pull that away while I find it for you real quickly. And won't let me scrub it. Hold on. Nope, don't want to scrub that one. Hold on. Trying to show you that my offset.
Let him.
The offset. Yeah. The offset. Hold on. Another one. I want to show you the offset. Give me a second to find the damn thing. Where the hell is my offset? There's the model I did. Give me a second. Give me a second, and I want to. Gotta be shitting me.
Being intercepted by the reinforcement of this floor.
Hold on.
Supporting it.
Oh boy. Okay. I think I know where to find it. I'm looking at the side screen, guys. Give me a second to pull it up. You gotta be shitting me. The rectangular array image. I'm trying to find the rectangular array. Oh boy. You can have that one back. You can have this one back for now. While I find that rectangular array image. Search. I've got a couple of drives I'm searching real quick. Yeah, I think I just found it. Nope, here it is. Okay. Then we have this one, the rectangular array. And lost it. It'll come right back, I think. And there we go. Rectangular array, where this is K. This is the one where they showed that deflection. This is, because they removed the BMA, this puts everything offset like this. This is in the drawings. This shows how much is offset. This is per the let me look at the book, per the 318 1977 ACI code. I literally have the hard copy in front of me. And what you see there is the violation. The combination is not more than 20% total combined in rectangular array. And I would consider this whole deck to be one unit because it's all interlocked with reinforcement. So as you combine these percentages, whichever you use the 14.6 here or the 50%, or the one down here even, you're way over. It explains why it cracked here, why you see that it pulled that deflect here. But interesting enough, it took 40 years. All right, it took 40 years, and the whole deck was askew. None of these things were lining up. It was all askew. This whole system. I get that they had a BMA going on over here. A BMA, if you want to say that. I'll trigger some of you. But some of these other offsets, they just are not logical. The offsets there. Besides car parking. That's the only thing that makes them logical. Besides car parking. The back wall is pretty consistent spacing with a little bit of offset, like 8 inches there. It's set back. That's the main column building. And then they change it to 8 inches. Besides parking spaces. Now, to end the video, I mentioned about that I think that all elevated parking garages should be considered like bridges and should be inspected every 2 years, like a bridge. Don't try to point towards a building what they're doing. They need to treat these elevated parking garages. Cars drive on them like a bridge, except for they park on these. Unlike a bridge, they park on them, which creates a lot of shock loading. And they do it forever, and unlike a bridge, they require no inspections besides what they've made up this one now for what, 40-year certification, and then now they change it to, I don't know, 11 years, whatever it may be. But it's a bridge. It should be every 2 years. 2 years minimum certification, and any fracture showing up, it should be that you need to shut down the bridge until you determine the bridge is safe. All right, so I appreciate you guys coming out. Thanks, Randy, for the money. Thanks, Randy, for the money. I'm going to buy SD cards with that. SD cards with your money. And now I'm trying to figure out where you are. It's not easy to find it sometimes. With the way I got these tabs set up. Okay, over here. Nope. Trying to find you, your comments. Oh, there it is. Gotcha. So it's an outlier if it has to be the same mix. Randy says if it's an outlier, it has to be the same mix. Yeah. Yeah, I get your point on that, Randy. Yep. Yep. Thank you. Thank you. SD cards, like I said. So, thank you. This is 3 hours. I wanted this to be 30 minutes, just so you know. 3 hours and 31 minutes. Now, when you guys see me do videos, and they're like an hour long, this is how long they take, and then I edit them down. But now doing the live, there's no edit. You're getting the 3-hour, 32-minute video. So take care, love you guys, and thanks for all the support. And because of your support, that's why I posted this again, because frankly, put me with that porn thing, that smoked me, boy. They won my ass. But then Chris, like Randy and Chris, like Randy just now, and Christine sending, slamming me with some donations. Yeah, they're not like, of course it's not 3 hours of my time, but it's the thought that counts. It's not always the amount. It's the thought that counts, to me anyway. And so the thought and knowing it's hard-earned money for you guys also, that I give it a higher value. So yes, thank you for your time, and I performed here. Perform, monkey, perform. I don't know if we're going to finish the rest of the content. If you guys want to, I can go and I have not made it past. So let me save that. I have not made it past oh no, I did skim a little. The next stage, they do a break in the meeting, and then they go on. That's right, I did do it past there. And this is where she talks about planter boxes being an issue, etc. But she's not mentioning that that's Tong Lee is the problem there, not the first engineer. That she points out, this lady here points out that these planter boxes were not part of the original plans. Well, part of the original plans had a BMA in it, an elevated deck. It had multiple beams in it. As far as these extra planter boxes go, this extension